So as I mentioned yesterday, the biggest problem you're going to have is time. When it comes to the CFQ with 100 questions, it works out to roughly 2 minutes per question. Now, clearly, you're going to get a couple of questions which you're going to be able to answer right away, those dumbass questions. But then, if you remember yesterday, there were a couple of like motors questions and transformers questions, which clearly are going to take a lot more time. So you have to figure out a way to manage your time appropriately, because nothing sucks more than realizing you've only got 20 minutes left and you still have 30 questions left to answer. You have to manage your time in such a way that you should actually have 20 minutes, like you should actually be done 20 minutes before the end time. So this is my way of taking a test. I've been using this my entire life. I came up with it in my brain, and for me, it works fantastic. And anyone I've suggested this to, they say when they've used it, it works really well as well. So here we go. How to take the test pointers. We are going to use the blank sheet provided. Ask for more if needed. I actually have an example. We got the skip it method, blah, blah, blah. So I've come up with this lovely quiz here of 10 questions. So the first thing I do is I sort my questions. I have that blank piece of paper, and on the right-hand side, I do 2 little columns. My first column, I actually literally do this. I do a little smiley face, and then on the other column, I do a little unhappy face. So the little smiley face columns, these are questions that I can answer, but I know they're going to take a little bit of time. So questions, if I get a question, I know it right off the bat, I'm going to answer that one immediately, no problem. But I get a question that I know how to do a motor question, but clearly it's going to take me longer than 2 minutes, or I know I'm going to have to go to like 4 different tables. So I'm going to put it in this column right here. So this one is for questions that I know I can answer, but they're just going to take a little bit of time. This column is for questions that I can't answer at all. I would only be guessing. I'm not going to waste time on them. I have no idea what they're asking me. I don't even know if the questions are in English. So it goes into this column right here. Sorry, I just got to stir my noodles. Am I eating spaghetti at 9 o'clock in the morning? Yeah, don't judge me. I'm an adult and I pay taxes. Okay, so based off of this sad little quiz that I came up with, question 1, what is your name? Okay, that one's easy. My name is Julia, so I'm just going to answer that one right away and put it on the Scantron. Yay me, God, I'm smart. Question 2, what is your quest? Easy. My quest is to complete the exam and pass, so I can answer this one right away. Awesome. Question 3, what is the air velocity of an unladen swallow? This one is tricky. I could probably figure it out, but it's going to take me longer than 2 minutes. So I'm going to put it into this column right here. Question 4, what is the minimum size of fire alarm allowed to be laid in a raceway? This one's tricky too. I can definitely figure it out. It's going to take me a bit of time hunting through the code book to find the answer. It might take longer than 2 minutes, but again, I know I can answer it, but because it's going to take me longer than 2 minutes, I'm going to put it in this column too. Question 5, as light from a star spreads out and weakens, do gaps form between the photons? I don't know, man. I don't know. I can't answer that. I don't think I could ever answer that. So I'm not going to waste any time on it at all. So it's going to go in my unhappy face column over here. Question 6, why do birds suddenly appear every time you are near? I know the answer to this. I'm going to answer it right away, mark it on my Scantron, move along. Question 7, what is Thevenin's theorem? Again, don't have a clue. I immediately know when I see that question, I don't know. I'm immediately going to put it in this column and move on. I'm not going to waste any time at all looking for it in the code book. I don't have it in my brain handy from theory class. I'm not like literally, what is Thevenin's theorem? No fucking clue. Write it in this column. Immediately move on to the next question. Question 8, what color do red and blue make when mixed together? I know this one. Awesome. Going to immediately answer it. Mark it on the Scantron. Move on. Question 9, what is the maximum overcurrent size for a 575? 60 horsepower synchronous motor with an 80% power factor. I can do it, but again, it's going to take some time. I'm going to have to go to table 45. I'm going to have to go to table 29. It's going to take longer than 2 minutes. So I'm going to put it in my I know how to do it, but I'm going to save it for later column. And question 10, can fire have a shadow? I don't freaking know. And again, I don't know. I'm not wasting any time. Can fire have a shadow? I don't know. That didn't format well. I'm going to immediately put it into this one and move on. So at this point, I've gone through, let's pretend this is 100 questions instead of 10. It should take you roughly an hour. Out of your 4 hours, it should take you roughly an hour to do all this and sort your questions. So let's pretend that this is 100 questions. This took me an hour. At this point, I've confidently answered 4 questions. I knew this one off the top of my head. I knew this one. So I know I have at least 40% because I've got 3 hours left, but I've already answered 40% correctly because I knew those ones. So now I can look at these ones, the ones that I know how to do, but I just needed a little bit more time. So now I can start knocking these ones off. Once I've done these ones, I can then, at this point, hopefully I've got half an hour left, 10 minutes left, whatever. This column shouldn't have that many. This one should only have maybe 10 or 15 questions in them. But because you just didn't know, you have no clue whatsoever, this one is just your guessing column. You wait until the very, very end before you do this one. Oh, hold on a second here. Because the big thing you have to remember, especially when it comes to the C of Q, is this question asking me what my name is worth the exact same 1 point as this one that took me 5 minutes to do. The what is my quest, the one that I was able to answer right away, is worth the exact same 1 point as what is Senoben's theorem. So you always want to knock off the ones you know how to do immediately, because again, it's really going to suck if you're at the 3.5 hour mark and you've got 30 questions left, and out of those 30 questions, you could have answered 20 of them easily, but now you don't have time. So you want to make sure that the first thing you do is get your scrap piece of paper, do the 2 little columns on the side, and sort. You answer the ones you can answer immediately. The ones that you look at, I know I can do this, immediately put it into this column. Next question. I don't know how to do this one. Fuck it. This column. Next question. I can answer this. Answer it. What's this one? I don't know. Here. Next question. Can I answer this one right away? Yes. Answer it. Can I do this one? Yes. Put it here. Next question. Can I do this one? It should take you roughly an hour to do 100 questions, but you're just going to go bang, 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 bang. And again, at the end of it, you're going to know I answered X amount of questions right off the bat. So if you answered X amount of questions right off the bat, now you know where you're sitting and you can kind of relax a little bit, because out of the 40% I got right, I only need to answer 3 of these correctly. These ones don't even matter. A 70% pass is the same as 100. So you can aim for 100 if you want, but it doesn't matter. The only reason it matters is for bragging rights. Now, the other thing that I do on my scrap piece of paper, so this is my scrap piece of paper like this. I've got my 2 columns here. I've got this big blank space here. Keep yourself organized. Keep track of your answers, because I guarantee you, at some point, you're going to accidentally fill in the wrong bubble on your Scantron. And if you do that, it throws all of the answers after it off, and it really fucks you over. Again, really sucks when you look and you realize that you've messed up, say, 10, 20 of your Scantron, and you have to go back and redo those questions. Keep track. Yes, what is my name? I just did a quick little question 1. My name's Julia. That's the answer. I did A. And then I do a quick little line around it. Question 2, what is my quest? The answer out of A, B, C, D was C. And then do a little thing. 3, again, 3 was in my I can figure it out later. So I just would do a little 3 and leave it blank. 4, that was I could save it for later. I just do a little 4, leave it blank. And then as I start going through these ones, Like as I had the 3, the 4, whatever. I go to 3, I find it, I go back to here and I write down B. I go to 4, I write down D, and I even write down really quickly the code. Because again, it's really gonna suck if you accidentally script your Scantron and you have to redo all the questions. What the hell? My cat's just knocked something over. I am so tired. I am so tired. Oh, you shitheads! Son of a... Sorry, give me a second. Rescue some cats, they said. You'll be a good person, they said. Son of a bitch. Such a good person rescuing cats. All 3 of them were found in a ditch. Freaking ditch kitties. Don't have cats, man. Okay. Sorry about that. Jesus wept. Ooh. All right, next slide here. Now, hard questions. I'm a big fan of rephrasing the questions. And I think that one yesterday we had about the centrifugal switch and the switch was left in the open position. That's a perfect example of rephrase the question. Get rid of any of the unnecessary information in there that's going to screw with you. And I do that literally in this little section here. I do the, what do I need to find? And I just put it in my little box here. Again, it doesn't matter that it was a centrifugal switch. It doesn't matter it was a single phase motor. Rephrase the question to only pick out the information that's necessary. If you have to find an overcurrent device for a motor, does the service factor matter? Like, does service factor matter when you're trying to figure out overcurrent? No, but they're going to put that in there anyway to fuck with you or screw with you, mess with you, whatever, sorry. So you want to take out the stuff that's necessary because again, they're absolutely trying to make you fail. So only pick out the stuff that's important. And again, this is what this is for. Write it down in your little question 8. I just need to find my flaw. I just need to find that. Table 29, tickety-boo, off to the races. The other thing is everybody always says, look for what you know in a question. I'm actually the opposite on that. If you're reading a question and there's something in there that you don't know, chances are you've had 3 terms of trade school. So you know the regular motor questions, you know the regular transformer questions, you know the regular install questions. So if you're reading a question and there's something in there that you've never seen before, that's the thing you need to look up in the index. That's the thing that you need to figure out. So one of the, hold on a second here. I'm going to write out a question here and I want you guys to try to do it. Let's see here, okay. What is minimum size of traveling? What is the minimum size of traveling cable in a lighting circuit? I want you guys to try to find the answer and let me know the code. I know some of you actually have your code books in front of you. Let me know the code for that. Is my spaghetti done yet? Oh, it's close. It's close. Do, do, do. Oh, was Shruggy singing that Jeopardy theme song? Do, 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 do. Remember, you only got 2 minutes. You only got 2 minutes. 2 minutes per question. There you go. Look at you, Jackie, on the ball. So how did you find it so fast, my friend? How did you find that so fast? What did you do to find that so fast? Traveling. Exactly. Because in all of your code, exactly, you went to the index, you looked up cable. And because in all of your code, in all of the code that you've been doing in all 3 terms of trade school, I guarantee you haven't come across that. So that's the thing you want to look up. What ends up happening is you get told by teachers to look for what you know. And that's okay for normal tests. But this is the C of Q. This is the C of Q that's trying to fuck with you. So looking for what you know actually works against you. Because if this was in a looking for what you know scenario, you guys would see lighting, you would go to section 30 and you'd be there forever because it's not there. Traveling, you've never seen before, you look that up and it sends you to section 38. Section 38, my friends, is freaking elevators. It's elevators, which I know none of you learned. But again, the C of Q is trying to screw with you. So all of the trade school you've done where that your code teacher, you did go to 30. Even after I told you specifically, Marcus, look for the words you don't know. So you fell into the trap. All of your trade school life, your code teacher has told you to pick out what you know. And again, that works for trade school. That does not work for the C of Q. You have to look for the stuff you don't know. And you don't know this, so you go to the index, you look it up, and it sends you to freaking elevators. I know it's unfortunate, but everything you've learned kind of in code is not going to, like all the tips and tricks you've learned in code, it's not going to help you for the C of Q. Because your teachers didn't design tests during trade school to fail you. They designed tests to try to test your ability. But they didn't design the test to try to fail you. The C of Q is specifically done to try to fail you because, again, they want to make your money. They want to screw with you. The amount of random questions you're going to get and you're going to waste your time looking for them because you were taught to look for what you know. I did mention to you guys yesterday that I just took my master's. So part of the master's is a section on the Ontario Codebook, not Canadian. Ontario Codebook is it's a lot bigger. It's got a lot more stuff in it. And I was, for obvious reasons, because I teach code, I was expecting to fly through it no problem. The masters did not ask me a single normal code question. I had a question, Jesus, about the supply conductors for a Ferris wheel. I had a question about the minimum wire gauge for a secondary ballast for a lighting in an amphitheater. There was one about the minimum ampacity or the minimum conductor size for an outlet on a floating dock. Because the masters is also trying to screw with you and make you fail. Again, cannot stress this enough. Look for what you don't know. Let me go back to this one here, taking the test. Okay. These are the generally accepted multiple choice tricks. You guys already know, you've taken enough multiple choice tests in your life to know how they work. The only difference with the C of Q is the C of Q very much loves to give you 2 right answers, but one of them is more right. Is it frustrating? Absolutely. Is it stupid? 100%. So you're very often going to have 2 right answers. You're just going to have to pick the one that's more right. Sorry to tell you. And again, this is the C of Q. Loves trick questions. If you think a question might be a trick, read it over again very carefully. Honestly, out of the 100 questions, roughly 60 of them, 60, are going to be a trick of some sort. They're going to put something in millimeters and you have to convert it into mils. And if you don't do that, you're going to get the question wrong. They're going to, I don't know, they're just going to do all sorts of shady shit like that. Now keep in mind, because I remember we did one of them yesterday, they know that you're going to screw up, so they'll still give you that answer. I think I mentioned that when we were doing the hermetic motors. for A, B, C, D, those 2 motor questions, they did 2 of the answers as if you had done it for regular motors, and they did 2 of the answers if you recognized and did it for cold motors. So you might walk out of there thinking, wow, I nailed that. And then you're very confused as to why you failed. Well, because they know how you're going to screw up and they give you those answers. So again, roughly 60 of the questions are going to be tricky. At some point, you have to check the notes, the asterisks, like that kind of stuff. Again, eliminate answers that are extremes are obviously wrong, blah, blah, blah. Again, a lot of this doesn't really apply to you guys because you're taking it on Friday, but get a good night's sleep, use flashcards, meow, meow, meow. Okay. Any questions based off of that? Did that seem useful, helpful? I'm just talking. Just talking at this point, just lecturing and talking. Okay, speaking of general trade knowledge. Speaking of general trade knowledge, who wants to do a bunch of really random general trade knowledge questions? These are the ones that you are just supposed to know. Now, I am going to tell you right now, in 15 minutes, we're probably going to take a 15-minute break because I'm starving and I want to eat some spaghetti. Okay, here we go. Again, ignore some of this stuff. 45 kVA transformer needs to be installed in the ceiling with a steel structure. What will you use? A tugger, scissor lift, chain hoist, or scaffold? I love how you all said C. That is correct. Now, what if this was a 45 VA transformer? What would you use? B, exactly. B. Again, is this a trick? Kind of. This is letting you know that it's a big one. And because it's a big one, you have to use a chain hoist. If it didn't have the K in front of it, that means it's a little bitty baby one, and using a chain hoist would be quite ridiculous, actually. How should a normally closed limit switch be connected in relation to other parts of a circuit? Wired in series with the holding contact, wired in parallel with the start button, wired across the holding contacts, or wired across the holding coil. Now, before you start worrying about this one, now again, this is the type of one where I'm like, can I figure it out? Yes, but I'm just going to put it here and move on. Immediately move on. I'm not going to spend time on this one yet. Now, when you get a question that asks you something like this, immediately go to the diagrams. Go to the diagrams and find one of the diagrams that has a limit switch on it. Because there will be at least one diagram. Just flip through real quick. That diagram has a limit switch, and you're just going to go, oh, there it is. Boom. So it's okay. First off, Ian, wired in series with the holding contact. Good God. No. What are you doing? No, it's not that one. It's not wired across the holding coil. And you guys said wired in parallel with the start button. Well, think about that. When have you ever seen a limit switch, a normally closed limit switch, wired in parallel with the start button? There you go. It's wired across the holding contacts. You will never see it like this. But again, this is an easy one, but it's a little tricky. Go to the diagrams. There is going to be a limit switch. Go to the diagrams. It might also, because both of these, this one is also right. This one is kind of more right, but this one's also right. So when performing interconnection to the main power, who should be consulted? City engineer, foreman, supply authority, or constructor? That is correct. C. So you answer that one. Go to your, what do you call it? Bubble sheet. Fill it out. Immediately move to the next question. What would cause a thermal overload to arc? Short circuit in the incoming power, momentary current spikes at startup, excessive heating due to increased currents, electrical loss due to hysteresis and eddy currents. Thermal overload to arc. Again, friendly reminder, if you don't know, there's only 3 rules to electricity. This is the first rule. This is electricity being lazy and throwing a temper tantrum. Max, you're going with A? We got C. Thermal overload, thermal, heat, excessive heating. This is the only answer that has the word heat in it. So if we actually think about this, short circuit in the incoming power means nothing's happening. It's dead in the water. B is also correct. But if you think about it, momentary current spikes at startup causes excessive heating due to increased currents. Electrical loss doesn't cause heating. Who is responsible for assuring that the trades be done in order? General contractor, foreman, supervisor, manager. Beautiful. Now, sometimes the general contractor and supervisor are the same thing. However, the answer is almost always general contractor. When is an extension cord inspected? After each use, before each use, daily or weekly? B, beautiful. Answer that on your bubble sheet. Move on. When can a service neutral be spliced? Don't guess. I don't want you to guess on this one. If you don't know, put in don't know. Don't guess. When can a service neutral be spliced? Approved connector in a large enough box when in concrete near service head. I just told you guys, if you don't know for sure, 100%, don't guess, because all of you are wrong. Congratulations, Madison's the only one who got it right. This is general trade knowledge, guys. So this isn't going to be in the code book. In your 2 columns, this one would probably go directly into the I don't freaking know. So you have to guess. Well, you don't have to guess now because I just gave you the answer. It's not a code question. We're doing general trade knowledge. All right, how are heating cables checked? Oscilloscope, Megger, ammeter, multimeter. All right, the answer on this one, multimeter. It doesn't matter that they're heating cables, guys. This is another perfect example of how do we check cables. We check with the multimeter. So what does an oscilloscope measure? What does an oscilloscope measure? Waves. So clearly that one's wrong. What does a Megger measure? Megger measures insulin resistance. An ammeter only measures amps. A multimeter measures everything. So we're clearly going to go with multimeter on that one. What is the name of the sensor used in grounding high voltage installations? Do not guess. If you don't know, say you don't know. Is it a PT, a CT, an RTD, or a zero sequence sensor? I like the unhappy face. First off, what does PT stand for? Potential transformer, exactly. What's the name of the sensor? That doesn't make any sense. CT, current transformer. That doesn't make any sense. What's an RTD? It's for temperature. So clearly that one doesn't. It's a zero sequence sensor. Now, again, you don't know this one. So when you've got your 2 thingies here, I would honestly, I would have popped that one right in there. Was I able to figure it out? Yes, but again, I've already passed my shit. I would have put that one there. I don't know. Don't waste my time. Moving on. Now, technically, you could put it in either one, but don't waste your time. Move on. How do we change? Ooh, that's a good one. How do we change the voltage of a generator while maintaining the frequency? By changing the field current, by changing the speed of the prime mover, by changing the coil size, by changing the load. You guys should be able to answer this immediately. Immediately. Anthony's on the ball. A, perfect. The prime mover doesn't have a speed at all. Do you guys even know what the prime mover is? You might get a question based off of that. The only difference between a generator and a motor is the prime mover. The prime mover. You may actually get that question. So if you have a generator and you have a motor, the only difference between the two is the prime mover. What that means basically is a generator takes an outside influence and turns it into electricity. Motor takes electricity and turns it into rotation, whatever, outside influence. The prime mover literally just switches that. So if you have a generator, you can actually turn it into a motor by flipping the prime mover in a zombie apocalypse. Why do we have a tag with the lock when performing tag out lockout? To know who locked it, to know what time repair started, to open the lock, and to know what time repair finished. A, beautiful. We already did that one, so we'll move on to the next one. Hold on a sec. Sorry, those aren't general trade. How is a telephone cable to be stripped and attached to a fish tape? Strip the conductors and attach to the fish tape. Fold over and attach to the fish tape. Wrap all the conductors into the fish tape hook. Tape the joints individually. Yes, these are questions you could get asked. Careful, we have 2 right answers. That one's not right. That one's not right. So out of those 2, which one's more right? Yeah, you guys are correct. It is A. How should a voltmeter be checked before using it on an unknown source? Short the leads and check for 0. Check the voltage on a known source. Short the leads and check for infinity, or no need to check. There are 2 right answers here. B is the right answer. A is technically the other answer too. But yes, B, live, dead, live. When should equipment have a lockout tag? During the day shift, on the weekends, when the equipment is being repaired? Never. Beautiful. C. If some part of work is canceled, what is to be done? Call the supervisor, make a new contract, arrange a safety meeting, nothing. Ooh, make a new contract. You would have learned that in level 1 Prince. When some or part of the work is to be canceled, you have to make a new contract. What is not an RV starter? Auto transformer, reactor starting, star delta, full voltage. This is one of my favorite ones. Hey, y'all are just guessing. Y'all are just guessing. First off, I'm going to ask you guys, what's an RV starter? That's nice. You don't know. There we go, Max. RV stands for reduced voltage. Reduced voltage. So it does not stand for recreational vehicle, which is annoying because there actually is a section in the code book on recreational vehicles. RV starter is reduced voltage starter. So Max, I'm a little confused that you knew it was reduced voltage starter and you picked auto transformer when clearly full voltage is right there. You absolute Brussels sprout. What is not a reduced voltage starter? A full voltage starter. Cheapers, Max. If I was giving away stickers, I'd take one away from you. What does PV stand for? PV. PV, photovoltaic, love it. What does backup stand for? Backup. Beautiful. What does three-phase, four-wire? What does that stand for? Why, but not just why, guys. Why with a neutral? Y can come non-neutraled. You can have a Y without the neutral. Do you know you can have a delta with the neutral? It's called high-leg delta. You do all sorts of fun shit with it. Okay, here we go. In addition to material descriptions, what other criteria must be included in specifications? This is going all the way back to level 1 prints. When inspections are scheduled, how the work is to be performed, when the material is delivered, when the work must be completed. I'm going to tell you right now, if I got this, I would have put this immediately into here, because this clearly is not in the code book, and if I don't have the knowledge, I can't magically come up with it. Specifications. Madison, I almost called you Maddie, sorry. Madison says B. Madison says B. Madison is correct. In specifications, you can't have anything that involves time. Specifications does not involve time. A involves time. C involves time. D involves time. Specifications does not have anything that involves time. How do you maintain the batteries of an emergency system? Should be half charged, fully charged, discharged, fully discharged. We're going to go with B. That one's fairly simple. I like this one here. This is a good one. What is the purpose of mechanical interlock in isolating switches? They are interlocks. They cannot be opened under load. They are interlocks so they can be opened under load. They're interlocks. They cannot be closed under load. No function. What do we think? We have to pay attention. A, they're interlocked so they cannot be opened under load. If you notice, B looks a lot similar. They're interlocked so they can be opened under load. We don't want to open shit under load. Stuff explodes when you open it under load. They're interlocked so they cannot. So you have to pay very, very, very close attention to how things are worded. Okay, this is a good question, actually. What would be the result if the end-of-line resistor developed a short circuit in a conventional system at Class A fire alarm circuit? The fire alarm panel will indicate a trouble condition. The circuit overcurrent device will operate. The fire alarm panel will be triggered to alarm. The fire alarm panel will indicate a ground fault. There are two right answers. This is the correct one. The only time a fire alarm panel is triggered to alarm is literally when there's a fire. Any other problem is trouble. Always trouble, almost never alarm. What is the drawing called when you make changes in the drawing during construction of a project? Do we know this? No. Immediately put it to one of your thingies. Move on. Oh, you guys do know it? A. Beautiful. I love it. What are the three components of the WHMIS system? Worker education, labels, and SDS. B. Worker education, the extinguishers and SDS. C. Worker education, labels, and PPE. D. Worker education, safety regulators, and SDS. Ooh, you guys are sucky at this. A. Worker education, labels, and SDS. PPE's got nothing to do with WHMIS. SDS, labels, worker education. That was an easy one. Now, aren't y'all going to feel dumb when you get a 69? This was supposed to be an easy one. Oh my, you guys are nailing the hard ones, but wow, you're really slacking on the easy ones. In an air intake unit, the air is flowing but is not being cooled. Why? Sales switch, heater coil, defective thermostat, low refrigerant. Guess what? No, don't guess. Don't guess. If you don't know, do an unhappy face. If you don't know, do an unhappy face. Don't guess. Max, if you don't know, don't guess. It's a sales switch. But guess what? Don't freaking guess. Immediately take it, put into your unhappy face column. If you're going to guess, wait till the end. You guys are killing me. What is the best position to run the wire between joists? On the edge, on the center, on the innermost edge, on the outer edge? Please, all of you, get this freaking right. Marcus, I swear to God. Marcus Brown, I swear to God. Thank you. You can't see me, but I'm shaking my fist at you. When is the rough-in wiring to be done? After the panel board is installed, after the roof is installed, after the windows are installed, after the framing is done. When is the rough-in wiring to be? Wow, you guys are really bad at this. You need a roof, guys. You need a roof. You're all killing me. You're killing me. Oh. Now, somebody's going to say, but at my job, that's great. They're testing you on things that how it's supposed to be, not what actually is. Like, how are we actually supposed to cut BX? According to CSA, with the hacksaw. You're supposed to, according to CSA, cut it with a hacksaw. Nobody freaking does. We do the snap, right? But according to CSA, you cannot technically do the rough-in wiring until after the roof is installed. It's just, you know, bend and twist. Yeah, snap. Okay, I'm not going to lie. It's been another hour, and I need to eat some spaghetti. So if we can take 10 minutes and eat some spaghetti, and I can give my voice a break for a minute. Boy. Hey, are we good with 15? I'm good with 15. All right. Love it. 15. 10:05. I'm leaving. Bye. One of the transformers became defective and was replaced. The newly installed transformer draws more current than the other. What is the problem? Incorrect voltage, lower kVA rating, lower percent impedance, incorrect polarity connection. What do we think? Now remember, there are only 3 rules. This one falls under the parallel rule. So let's try this again. There's only 3 rules, my friends. This literally says parallel in it, so it falls under parallel rules. If it's drawing more current than it's supposed to, that means what? What happens when you put two things in series? What happens if you put two things in parallel? Starts screwing up, draws more current than it's supposed to. Incorrect polarity connection. This falls into that parallel, shares the current thing. Which of these components creates a fire hazard when they are mixed together? Fuel, air, and wood. Ignition source, oxygen and air. Ignition source, wood and paper. Fuel, ignition source, oxygen. This is an easy one. Boom. But Madison, get your shit together. Exactly. My God. Try again, Madison. There you go. Cheapers. How is an inverter on a PV system installed? Supply side of the panel, load side of the panel, supply side of the transfer switch, load side of the transfer switch. Anybody happen to know this off the top of their heads? Well, it's not going to be on the supply side of the panel because that would make everything blow up. Is it going to be on the load side of the panel? Supply side of the transfer switch, load side of the transfer switch? Load side of the panel, because this is the load. So it has to invert before it hits the panel. Transfer switch has nothing to do with it. Woo! What is used as a disconnecting means for a motor? Relay, contactor, switch, 30 amp twist lock plug attachment. What are we guessing? Are we all guessing D? So you're telling me for all motors, every motor ever invented under the sun, you can use a 30 amp twist lock plug? Disconnect's not an option, you potato. So this is another perfect example of pay attention. Both of these are right. If this had just said a twist lock plug, this one would be right. But because it specifies 30 amps, then you have to go with switch. So if you have the option, you always go with twist lock plug. But because this one is too specific, then it's wrong and switch is the correct answer. Why would a motion sensor keep tripping? Wrong spot, sensitivity adjustment, range, faulty sensor. Why would it keep tripping? We got two right answers. One of them is more right. It's in the wrong spot, my friends. Sensitivity adjustment is also right, but wrong spot is more right. More right. Isn't this fun? Isn't this fun, guys? We're having fun, right? Bro. Oh, okay. Which equipment would you use to install a light 5 meters above a staircase? Step ladder, extension ladder, scaffold, or scissor lift? C is correct. You may also, they may have changed it up. If you see something called a baker's something or other, baker's is technically the correct answer. Baker's, what the fuck's it called? Baker stage. If you see the term baker stage, that is more correct. But yes, scaffold. What type of screws would be used when installing an EMT conduit to a masonry wall? Machine, wood, metal, concrete. Thank you. Okay, every once in a while, I start to worry about you guys, but you came back, so I like that. When replacing a 5 kV motor, what is checked first? Again, the 5 kV doesn't matter, right? It's just when replacing a motor, what is checked first? 0 rotation, 0 potential, 0 power, 0 current. Okay, try again. Try again. There you go. Zero potential. Zero potential and zero power are not the same thing. Zero power just means you've hit the off switch. Zero potential means it's been disconnected from any possible electrical source. So it's always B. 3 single-phase transformers are connected in a bank. Boom, 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 draw it out. And placed in operation. After several months, all of the motors connected to the transformer bank are burnt out. What is the cause? One transformer has an open circuit. One transformer is a short circuit. The connected load contains harmonic distortion. The load connected is unbalanced. Gee, I like this question because the first thing you have to ask yourself is, would this be a transformer problem or would this be a load problem? If only one of the motors had burned out, it would be a motor problem. But because all of the motors have burned out, this makes it a transformer problem, which takes out C and D. And again, there's only 3 sets of rules. Lazy, series, parallel. Open is series, short is parallel. So if the transformer bank burns out, all of the motors burn out, what would that be an indication of? Burning. Burning. Is burning a series problem or a parallel problem? Guys, burning is a series problem. Series is an ass. We like our asses thick and juicy. High torque, high amps. Burning is a series problem. But this is a perfect example of, is this a series problem? Because this is a series answer, or a parallel problem. Short circuit is parallel. Open circuit leads to burning. What wall support is used to prevent an electrician from having to bend an offset into a box? Offset clip, strut support, U-clip, angle clip. What wall support is used to prevent an electrician from having to bend an offset into a box? Okay, guys. I love you all so much. It's literally right there. It's literally right there. It's offset clip. It's right there. Okay. When conducting maintenance on a fire alarm system, what is to be done? Call the fire station and shut off normal power. Shut off normal power. Call the fire station and inform the customers of the maintenance. Call supervisor. There are 2 correct answers. Which one are we going to pick? That would be correct. C. C is correct. When replacing an electrical furnace, what is the proper procedure? Lock it, de-energize, replace, energize, unlock. De-energize, lock, install, unlock. De-energize, replace, energize, de-energize, lock, install. What is the first thing you always do? Always, always, always. The first thing you always do. Okay, and then? Okay, so what's the only one that has that? B. This one doesn't count because it's not as specific, I guess. Oops. Next page. How many of these questions do you have? I don't even know, man. A lot. Where should powder actuated material be stored? In a cool, dry place, hot, dry place, damp, or locked? There are 2 right answers. Which one is more right? Well, you guys are both picking the 2 right answers. In a cool, dry place. Locked room is also right, but cool and dry place is more right. On which drawing would the thermostat be located? Distribution, power, lighting, or fire alarm? Which drawing? There's 2 right answers on this one too. Both of these are right answers. Which one are we going to pick now that I've told you both of those are right? You're still going to go with C? I love it. Sometimes you will find in industrial, the fire alarm and thermostat, they are on the same because you got your HVAC system and stuff, but this didn't specify industrial, so you'd go with regular. What type of supports can be used in a combustible area? Wood and aluminum, wood and fiberglass, steel and aluminum, wood and steel. Thank you, Madison. I thought you were going to go for wood again. Mwah, mwah, mwah. In a building, the thermostat is set to 22 degrees, but the actual temperature is 15 degrees. What is the reason? Faulty thermostat, thermostat is installed too high up, improperly programmed, or none of the above. So it's set to 22, but the actual temperature is 15. Set to 22, but the actual temperature is 15. You guys are killing me. I don't keep meaning to draw dicks. Sorry, it's not on purpose. The thermostat is installed too high up. So it's set at 22. I can't, 22, but the actual room is 15. Because it's set too high, it's not registering the actual temperature. So it thinks the 15 of the room is actually okay because the air is hotter up here. So it's registering this up here at 22. That's exactly it. Heat rises. So because it's installed so high, it's acknowledging up here is 22. Down here where we're supposed to be is 15. So if it was lower, it would have said, oh, it's 15, and when it would turn the shit on. When does the generator start? When the main power goes out in hazardous locations? Not at all. After a time delay, right away, after a 10-second time delay. The answer is always right away. It does not matter that it's a hazardous location. They put that in there to fuck with you. Generator always has to start right away. Right away. Oh, we already did that centrifugal switch one. On a regular maintenance of a generator, it is found that one of the batteries in a battery bank is drained at a current. Oh no. What is the corrective action? Replace only the dead battery, recharge the battery, replace all batteries, do nothing. If a battery in a battery bank is completely drained, all batteries, correct. How often should a visual inspection be done on high voltage gloves? Weekly, monthly, every 3 months before each use? Please tell me you know this one. The answer, of course, is 6, even though that's not one of the answers offered. Thanks, Max, for that. Yes, Beverly, it is D, before each use. What is used to measure 4,000 degrees Celsius? Thermometer, thermistor, pyrometer, pottermeter. And yes, I know it's pronounced thermometer, but I like saying thermometer. What is used to measure 4,000 degrees Celsius? Thermistor, thermometer, pyrometer, pottermeter. I like that. What's the word? Okay, for those of you who watch X-Men, what is Pyro's mutation? What's Pyro's mutation in X-Men? He's fire. So we're looking at 4,000 degrees Celsius. 4,000 degrees Celsius kind of seems like fire to me. So you'd go with a pyrometer or pyrometer. I don't know how the hell you pronounce that. Yeah, okay. I don't need the attitude, Darren. I already passed my C of Q. Okay. Okay, your face. And I forgot to put the actual things there. In a commercial building with an integrated building automation system, what effect would the fire alarm system have on the HVAC system? The fire alarm must close all supply dampers. The fire alarm must close all exhaust dampers. The fire alarm must shut down the HVAC system. The fire alarm must not interfere with the HVAC system. Ooh, we like this one. Oh, you guys. Oh, yeah. Keep going. It's A. There you go. A. Oh, that was the last one. Nice. That was the last one. Do we have any questions? Any questions about anything? Yep. Oh, then I was gonna find it somewhere. Nope. 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 Was it this one? Was that? No, that's not it. Never mind. Sorry. Nope. Was it this one? Was it this one? Yes. Okay. Hold on. Okay. So what do we need? A longer explanation of what? What? Okay. So, oh, I guess we'll just have to draw it like this. I don't know. So this is a it says 2 3-phase transformers. So you have 2, 3. I probably should. Okay, we'll just are connected in parallel. So they're connected in parallel. Because they're connected in parallel, what stays the same? The amps, right? Try again. Jesus, I'm tired. Voltage. So the voltage stays the same. The amps change. Now, one of the transformers became defective and they replaced it. Transformers have to have the same voltage. And, I do this again now. So now, good God, Julia, try this again. We'll go like this, like that. So now what we've done is now we've connected them in series by accident. We've increased the voltage and we've turned them into series as an ass, and it's not meant to. So because they're supposed to be connected in parallel and the amps are shared, we have smaller wires, right? So if we connect them with incorrect polarity connection, so now we didn't put the transformers in parallel, now we put them in series. Series is an ass. So we took, before when it was parallel connection, let's say it was 45 amps for each, by accidentally putting them in a series configuration, this wire here was sized for 45 amps, but now we've asked them. So now we have 90 amps going through a cable that was only meant to handle 45. So it's drawing more current than the other. And what's eventually going to happen, it's going to burn out. So we took something that was sized, installed, everything was done appropriately for parallel connection where the amps share, and we accidentally turned these transformers into a series connection. And by turning them into a series connection, now my amps stay the same. So my input ampies, which is say 90, instead of being split between the two parallel transformers at 45 amps, by doing the incorrect polarity, we accidentally took that full 90 amps and shoved all 90 amps into a wire that was only meant to handle 45. But does that make sense? The lower kVA rating, no, because kVA rating is going to change based on the amps. The voltage is always going to be the same, but the amps are always going to change. You can have 3 single-phase transformers. This could be 600 volt. They're all 600 volts, but this could be 10 amps, 4 amps, and 2 amps. So your kVA rating is going to change no matter what. That's not an option. Your impedance, try to explain impedance here. Your impedance is based off the short circuit. Does that, do you guys remember, did you do impedance with the short circuit stuff? Like the short circuit impedance, short circuit to ground, all that other stuff, fault current? Yeah. You guys did that with transformers? So impedance isn't going to cause any problems with this because, hold on. It's a good question. I'm trying to figure out how to explain it. Was it just 2 3-phase transformers? Okay. Impedance isn't going to cause a problem with this because the fault current, if you have to think back to going all the way back, because the 90 amps was coming in originally, our fault current impedance was based on the 90 amps. So even though it's in parallel, this is 45, this is 45, your impedance was based on the 90 amps anyway. So your impedance is the same whether they're paralleled or seriesed. Yes, that's a good explanation. Okay. So incorrect voltage and incorrect polarity connection are the same, but the fact that it draws more current means it's the incorrect polarity because you took something in parallel, you accidentally put it in series. The shit's not supposed to be series, so now it's drawing 90 amps instead of the split 45s. There you go. That's a good question. I like that question. Made me think. I like thinking. One of the things I do best. No problem. What other questions do we have? Anything? Anything? Okay, so out of curiosities, was there anything specific you guys wanted from me today? Like, hey, Julia, we'd really like to focus on X. Or, hey, Julia, can we do more of Y? Or, hey, I looked through your PowerPoints and would you mind going through a specific PowerPoint with me? Is there anything, because this is your class, so is there anything specific you guys want? As many questions as we can get through. Okay. Well, the only reason I'm saying that is because tomorrow and Thursday, you're just going to be doing a shit ton of questions. So that's all you're going to be doing all day tomorrow and all day Thursday. So today's the day to ask if you have a problem with something specific or to break something down, to ask me, because all that you're doing is just nothing but questions for the next 2 days. Motor questions? Love motor questions. Load calcs, like a service? Do you mean just like a house service? Or apartment service, or what do you mean? There is, as a heads up, there is a ridiculously hard load calculation question for a house in the C of Q. It would probably take me, and I know what I'm doing, it would probably take me minimum 5 minutes to do it. Fastest way to do a surface calc. Now, I have both demand calc for a house and demand calc for an apartment. I have both of those in PowerPoints. There is no fast way to do a service calc. There is no fast way. The only thing you can really do, hold on a second. Let me find this here. When you're doing, a service calc for a house or an apartment, you want to remember, if it's hot, it uses a lot. So that applies to 2 things. If it's hot, it uses a lot. 1, if it's hot, it uses a lot. It's going to be 240 volts. And 2, you're almost exclusively going to take it at 100% demand factor. If it's hot, it uses a lot. Going to take it at 100%. So a sauna, is it hot? Is a sauna hot? Yes, we take it at 100%. Hot tub, is it hot? Take it at 100%. Your furnace, is it hot? Take it at 100%. Baseboard heating, is it hot? Take it at 100%. Now, the one trick to baseboard heating is, it's first off, it's in section 62. The first 10,000 kilowatts is taken at 100%. Anything over 10,000 is taken at 75%. It's kind of the same with the stove. The stove is hot, it uses a lot, but if you guys remember, the stove has that really stupid rule. You apply 6,000 for the first 12,000 and 40% after. So the stove is the only one that doesn't follow the if it's hot, it uses a lot rule. Your AC, is it hot? Yes, Madison, it is. Your AC thingy that's installed outside your house, it's hot as shit. If you've got one of those AC things installed, the AC box is installed outside your house, go friggin' touch it. That mofo gets hot as hell. Oh, okay. Either way, AC is considered hot. It uses a lot. So it's 240 volts. AC is at 100%. So if it's hot, uses a lot, take it at 100%. The other rule to remember is if it doesn't have its own code, it's considered an extra load. I like with the rhyming. If it doesn't have its own code, it's considered an extra load. So a dishwasher does not have a code, considered an extra load. Dryer does not have a code, considered an extra load. Refrigerator doesn't have a code, considered an extra load. And everything with an extra load is you tally it all up, take it at 25%. So you just remember, if it's hot, it uses a lot. Lighting, we don't do lighting. That's lighting is under, oh, what the fuck's it called? Basic load. So if you guys remember, basic load covers all lights. I can spell load. It covers all lights and outlets. And that's based on your square meters. And then if it's hot, it uses a lot, 100%, except for the stupid stove. And if it doesn't have its own code, it's considered an extra load. Then you add everything up, divide it by 240, and that gives you your amperes. And then after you have your amperes, you can figure out your overcurrent, your panel size, and your wires. So when you're doing this, again, if it's hot, it uses a lot. If it doesn't have a code, it's an extra load, additional load. Okay, let's see if I have motor ones here. I think I might have actually done a motor. Oh, sorry, this isn't motor questions. This is motor general trade knowledge. Okay, hold on. So when it comes to, I think I did this for you guys yesterday. When it comes to motors, I have a set way of doing things, and I do the same thing for transformers as well, as I do a little chart. Because especially when it comes to motors, again, there's so much goddamn information that it's hard to pick out, what you need. So what's the first question we always ask her? You only consider extra loads if they draw more than 1,500 watts. That is correct. Yes, that is correct. Anyway, back to motors. What's the first question when you see, first thing you ask yourself when you see a motor question? First thing. Hot or cold? Beauty. So we're going to pretend we got hot motors. Is it hot or cold? We're going to pretend it's hot motor. And I do this for every motor. I go flaw, conductor, overcurrent, service factor. Conductor depends on if it's continuous duty, otherwise it's table 27. Overcurrent's table 29. Or what did I say? Service factor. Try that again. Overload. Yeah, overload. Conductor's table 27. Overcurrent's table 29. And this is service factor. So I always get my flaw. I put my flaw here. I figure out either if it's continuous duty, so if it's continuous duty, it's 1.25%. And then I take my flaw, do that. Here's my number. If it's overcurrent, I go to table 29. I figure out what the multiplier is. Let's say it's 250%. I then take my flaw. I go like this. Here's my overcurrent. Service factor, figure out if it's 1.15 or 1.25. Let's say it's 1.15. I take my flaw, I multiply it by this, and I go like that. So by doing it this way, I'm able to pick and put things where they need to be. So it's nice and all, I take the words and then I put them like this. So actually, hold on, let me find, I have to find my, sorry, I'm just looking for, there we go, individual motor calc, download. Okay, and now I have to upload it. Give me a second. Browse for files. View and upload. Sorry, I was waiting for it to upload here. Boop, 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 boop. It's a big one. So for anybody who hasn't actually gone through the PowerPoints that I've put up, this is the individual motor calculation one. Apparently didn't upload properly. I want to make sure, in case you guys are not aware, but when it comes to motors, this is not the same as this. So 4-006, where if it's unmarked or there's not a termination temperature, only applies to this portion here. There is a specific rule. This is 75 degrees here. Did you guys know that? So you might end up with a number 3 here, and you might end up with the number 8 here. Okay. Oh God, beauty. I love that. I love that because you guys already know about that one. Hold on. Boop, 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 boop. So anyway, this is how I have it laid out this here. So in this case, 230 volt, 3-phase squirrel cage induction motor, full voltage start, service factor of 1.15. Great. Awesome. Let's say the question is specifically asking me about what size of, that's a circuit breaker, because there's not a circuit breaker thing. I do exactly what I mentioned I do with my thing. And on my scrap piece of paper, let's say this is question 35, I would do 35. And then I go like, I literally go flaw. And then I go, okay, go to table 45. It's 3-phase, 230 volt. My flaw is 56. Beautiful. And it's asking me about overcurrent. So I do this. I go overcurrent. It's asking me about a circuit breaker. Awesome. I'll even write circuit breaker down. It's supposed to be a B. Little arrow. I go to table 29 and it tells me it's 2.5%. I go, great. And then I multiply these two together and then I get whatever that is. And then I go to table 13. Me personally, again, I just like doing it this way because I can pick and choose what I put in my little chart there. I'm trying to see if I have just, I may have to open up my laptop and email myself some stuff because I don't know if I have just motor questions here. Go back. You guys just want to do motor code questions? Would they put T13 and calculated answers? I don't know what you're asking, Ian, sorry. Still don't know what you're asking. Okay, I'm sorry. Okay, I'm sorry. I know I've got a crap ton of motor questions. I just have to figure out where the hell I put my laptop and email them to my tablet. So give me like, give me a couple seconds. Sorry, I'm still organizing. Email the stuff to myself. What? Do I sing to myself while I get things done? The answer is yes. There was an old farmer. He sat in the meadow just shaking his fist at some boys who were down by the creek, their hands in the water. There we go. Found some. Do you know that song, Jackie? I thought I was the only one that knew. It is. I thought I was the only one that knew that. Well, 10 points to Gryffindor. Okay. Friends. A 3-phase, 20 horsepower squirrel cage induction motor, Class A, has a rated flaw of 40 amps and is for use on continuous duty. What is the minimum size of NMW conductors that are required to feed the motor? Termination temperature is 75 degrees. So as per usual, the first thing, get out of here, I do is the same thing as always. I figure out my flaw. Now, I've got a horsepower rating, but I also have my flaw. Which one trumps? Do we go with whatever table 45 says? They use the flaw they gave me. So it's 40. I do that. It's asking me for minimum size conductors. Beaut. So there's only two things I need to ask myself when it's conductors. Is it continuous duty or non-continuous duty? This one is continuous duty. Beautiful. So it's, 1.25%. So I just take those two, multiply them together, and I lost my phone. Yeah, the flaw. I can say FLA until my friggin' feet bleed. Flaw. Marcus, I don't trust your math. It is 50. So it's 50 amps. Now what am I going to do? It's 50 amps. Where am I going to go now? Table 2. Beautiful. What if it was aluminum conductors? What if it was free air copper? Beauty. Okay, so I'm going to go to table 2. What column am I going to use? You were all completely wrong. You were all completely wrong. We are not going to use... Max is right, but why? Max, why are you right? No. I have Class A, which is telling me, I think, 90. I have a termination temperature, which is telling me 75. What's my insulation rating of NMWU, guys? What's my insulation rating of NMWU? Again, do not assume you know. You're going to go to table 19 because you're not familiar with NMWU. You're going to look, NMWU is only rated for 60. We always pick the lowest one. So even though this is Class A, even though the termination temperature was given as 75, NMWU is rated for 60. So which column are we going to use? We're going to look the 50 amps up under 60. This is a test I give to my people. I need to, because I try to express the importance of the C of Q is going to screw with you. 100% they're going to screw with you. Is it a number 6? I don't have my code book in front of me. I don't remember. Okay, hold on a second. What is the minimum size of R90 copper conductor in conduit that is required to supply a 575 three-phase wound rotor motor with an insulation class of F and full load amps of 60. I'm going to do the same thing. Going to go flaw. My flaw is given. It's 60. Beautiful. Love that for me. It's asking for minimum size of conduit or conductor. I only have 2 questions for conductor, continuous or non-continuous. This one is clearly continuous. So 60 times my 1.25 gives me what? What does it give me? Is it 75, Marcus? Is it 75, Marcus? Thank you. 75 amps. So pick copper conductor and conduit. Beautiful. It's crammed into some conduit. We're going to go to table 2. Which column are we going to use? We have class F, which I think is like 100 and the fuck is class F? I think it's 110. That sound about right for class F? Yeah. See? Look at, I know what I'm talking about. So class F is telling us 110. R90 is telling us 90, but my termination temperature is 75. So which column are we going to use? $75. Always go with the low. Oh, so yeah, sorry, this is one of the tests I give them, so there's some other random shit in here. Hold on. This is lighting stuff. Here we go. What would you assume if it doesn't say? So you'll notice when you look at table 37, it says totally enclosed, non-ventilated, and all except totally enclosed, non-ventilated. So when it comes to assumptions, the assumption is always what's the most common. So if it doesn't say copper, aluminum, we assume copper because copper is the most common. If it doesn't say free air crammed into conduit, we assume crammed into conduit because that's what's most common. If it, well, there's a whole bunch of assumptions we make. Oh, if it doesn't say a number 14, if it doesn't say stranded or solid, we assume stranded because stranded's most common. So what's more common, totally enclosed, non-ventilated, or everything else? Everything else, exactly. Now, it is going to, and you have to be careful because it may say totally enclosed, fan cooled. Totally enclosed, fan cooled is considered everything else. So like you just, again, you have to pay attention to the wording, but 99% of motors are ventilated in some way. Totally enclosed, non-ventilated is almost exclusively used in hazardous locations where you can't have any sparks, any fumes, and hospitals. Where there's the, like, because the hospitals are technically considered a hazardous location because of the oxygen bottles and all that other stuff. Most of the time, they have to be fan cooled, whatever. So that's what you would assume. Okay, so we have a squirrel cage, beauty, induction motor, class A is a rated FLA of 40. And for use on continuous duty, well, we already know how to do that. Okay, what is the maximum size of time delay fuse that we would install for the overcurrent protection of a motor at 40 flaw if a full voltage starting method is used? Again, we just do our flaw. Gives me my flaw of 40. This one's asking for overcurrent. Overcurrent, automatic table 29. This one is saying time delay fuse, so I just do a little time delay. You could use D16, absolutely. You can absolutely use D16. Friggin' mint. Just make sure you go to the right column. Make sure you go to the 3-phase squirrel cage, find your flaw, okay? Because on D16, it says single phase, 3-phase, and then DC and wound rotor is its own separate thing too. So this one's squirrel cage, so you use that one. But the last question we had was wound rotor. I'm trying to see if I have some nasty ones in here. Did I give them any nasty ones? Let's see. Sorry, I'm just looking at. I'm almost positive I gave them some nasty ones. I think this was the hazardous location one. Basic care. Actually, you know what? These aren't motors, but this isn't the worst thing to do here. Demand factors for a school or building with an area up to and including 900 meters squared based on the outside dimensions would be, where do we go to find this? Because again, remember, this right here is going to be in section C. How do we install this shit? When we are in section C, how do we install this shit? What's the first thing we ask ourselves? Is there a table for this? Because Grant, there's gonna be a table. Is there a table for this? Yes, there is a table for this. Is it 11 or 6? I think it's table 11. I'd have to double check in my brain, but I'm pretty sure it's 11. Same with this one. Is there a table for this? You're in the C of Q, you're in section C. Was it 14? Thank you. You're in the C of Q, you're in section C. Is there a table for this? Is there a table for this? Is there a table for this? This one here. Is there a table for this? Yes. Oh, here we go. I like this one. An apartment has a calculated load of 25,000 watts. What size of TW is required to feed the panel? So what are we going to do with this question here? No, Max. No. No, Max. Bad Max. $25,000 watts. What do we need to know to figure out what size of cable we need? We always need our amperes. So 25,000 divided by 240 gives me what? Somebody math that for me. 104. So an apartment has a calculated load of 104 amps. What size of TW is required to feed the panel? So we know it's 104 amps. Where do we go now? No, we already know the amps. Oh, maybe. Okay, why are you going to table 19, Anthony? Why is Anthony going to table 19? Yeah, there you go, babies. And what is the rating of TW, my loves? 60. So we're going to go to table 2 and we're going to go to the 60-degree column. Because if you notice, this question, again, doesn't mean for it to look like a dick, sorry. This question doesn't have a termination temperature, which means this question 4-006 applies. We had a calculated ampere of 104. So if this was R90, we would have used 75 because there's no termination temperature mentioned. It's over 100 amps. We would use the 75-degree column. But TW is rated for 60. So we have to use the 60-degree column. Don't you wish you were in my code class? All my guys are so prepped. They already know. This is because I fucked with them so much doing this shit. It's not conductor trumps. It's literally whatever is the lowest. So it's a mix of, if it's a motor, whatever class it is, it's a mix of if a termination temperature is given or not given. So 4-006. And it's also insulation rating, but it's also a mix of if there's another code. Like when we were doing motors, and you guys said you knew that like this and this were different, 4-06 applies to this one, but there's a specific code to this section that just tells you 75. So you have to mix and match between, if it's a motor, is there a class given, termination temperature, insulation rating of the cable, and, you know, like, so the shaft is an understatement, sorry. You guys are doing really, really well, though. You guys are doing you're actually doing a lot better than the last group B I had from Sheridan, so I'm very impressed. Like, you guys are getting some pretty simple questions wrong. Yeah, absolute freaking mashed potatoes, but you're doing pretty good. You're doing pretty good. So we look at this one, same thing. Apartment is a calculator, 36,000 watts. Equipment is marked for 75. What size NMWU is required to feed the panel? You take this, divide it by 240. It's going to give you something. Equipment is marked for 75, but don't assume you know what this is. Go to table 19, double check, because this little frigger is 60 degrees. You always go with the lowest one. If a motel unit also contains built-in cooking facilities, how are we to consider it so we can properly calculate the demand load? What section do we go to for this? 8. Now, you can't find it in 8. So what are you going to do? Thank you, Max. Appendix B. Appendix B is going to tell you it may be considered an apartment building. If you know for absolute certainty something should be in a section and it's not, you always go to the appendectomies, B, C, Q, D, L, whatever. It's going to tell you, go to Appendix B, go to Appendix D. It's always going to tell you. Not to be confused with if you're not sure, like that traveling cable question in the lighting circuit I gave you. Again, you can go to lighting, but again, you don't know for sure because that traveling cable part of it. But if you know for a fact that this should be in section 8 and you can't find it, yes, you hop into the appendectomies. Why? I thought I had more motor questions. I'm sorry, I don't think I do. This is the same one I just had. Yeah, sorry, I thought I had more. No more hints today. I already gave you all of them. I happen to know for a fact that, yeah, all the ones I gave you yesterday, the hints, there's those very specific capacitor questions. I know that there are the cold motor, that's what I was going to do with you, the cold motor questions. And you guys said you weren't familiar with cold motors. That's what I was going to do with you guys. Here we go. Cold motors. Want to do some cold motors? Yeah, let's do it. I like it, Ian. Thank you. So again, is it hot or is it cold? You're like, oh, it says rooftop cooling unit. Damn it, that's a cold motor. Julia told me about this. It may also say hermetic, again, or refrigerant compressor motor. Now, this is going to get really confusing. Just try, God. Okay, so hermetic refrigerant motor compressors, cold motors, differ from standard electric motors in a couple of distinct areas. Firstly, and I'm not going to keep repeating this, a cold motor is different. It has no external shaft. The motor itself operates in the goo, the refrigerant goo. Secondly, cold motors do not have a horsepower rating. Cold motors are not horsepower rated. They're rated instead by something called rated load current. If you see RLC, RLC also means that question is about a cold motor. So instead of saying flaw, if you see RLC, it means cold motor. Now, the RLC and the flaw are the exact same fucking thing. So if the flaw for a hot motor is 15, the RLC for the cold motor is also 15. They're the same number. But a cold motor, it's not called a flaw, it's called a rated load current, RLC. Okay? So if you get a question that says it's 50 horsepower with an RLC of 60, immediately go, this is a cold motor. Oh, this is a whole bunch of crap that you guys don't actually need to know because I'm not teaching you. Okay, so these rules, 28,700. Yes, hold on, Ian. Slow down, Ian. Just slow down. We're taking this baby steps here, okay? Slow your roll, bud. Cold motors is 28,700, so it's near the back of section 28. AC units, freezers, anything cold. So if you see hermetic, refrigerant compressor, or RLC, cold motor. Slowing your roll is not your strong suit, Ian. I feel badly for your girlfriend or wife. Sorry. That was very inappropriate. My apologies. I'm funny. Okay, so are you ready? Flaw versus lurk versus Rickle. Full load amps versus locked rotor current versus rated load current. So I'm just going to say flaw, lurk, Rickle. So remember, cold motors used are Rickle, rated load current, which should be marked on the motor, or the locked rotor current, the lurk, for certain calculations. Our flaw and our Rickle are the same thing, okay? But again, if you see Rickle, it means cold. Our lurk is either the flaw times 6 or the Rickle times 6. That reason is because of inrush current. Our inrush current for cold motors is referred to as locked rotor current, or lurk. It's the excessive current flow experienced within a motor and its conductors during the first few moments following turning the motor on. The reason with cold motors, we have our Rickle, our rated load current, but we have to multiply it by 6 to get our locked rotor current for inrush current, is because when you have that cold motor and the motor, all the internals are inside all of that goo, it needs extra amperes to go in there and mess and fuck with the goo in order to get the motor to work. So it has to have 6 times the amount of inrush current that a hot motor has. Sometimes we use the RLC. Sometimes we use the LRC. Yes, it is confusing. Sometimes we're going to use our Rickle. Sometimes we're going to use our lurk. No, we're gonna slow down, Ian. We're gonna slow down, Ian. Let's just explain what I just said. Now, if the I was about to say lurk. If the lurk locked rotor current is not on the motor, you either take the Rickle or a flaw and multiply it by 6. Is air compressor a cold motor? No, air compressor is a hot motor. Like a regular air compressor is a hot motor. Refrigerant compressor is a cold motor. Okay, so if the question just says 3-phase, 50 horsepower refrigerant compressor motor, and it doesn't give you an RLC, you pretend kind of like it's a hot motor. You still go to table 44, 45, whatever. You find the flaw. Because remember, the flaw is the same thing as our Rickle. So that's probably what's going to happen. You're going to get a question that says 3-phase, 600 volts, 3-phase, 50 horsepower air top cooling unit. And it's not going to mention anything else. So you're going to find the flaw as if you normally would. But that flaw, because it's a cold motor, it's not technically a flaw. It's an RLC. Okay. Here's some questions. A single-phase hermetic refrigerant motor compressor is rated for 5 horsepower or 208 vac. What is the locked rotor current rating for this motor? Okay. The lurk is the flaw times 6, or the Rickle times 6. So we have to find a regular flaw. So we go to table 45. We find our flaw. Our flaw at this point is 28. But again, we have to pay attention because it says 208. We go down to our notes and it says for 208 volts, you have to do the multiplier, right? So we end up with the flaw of 30.8. Again, our flaw and our Rickle, rated load current, same thing. We're going to multiply it by 6. That gives us 184 amps. So if this was a hot motor, we would be using this to figure out our overcurrent, our overload, and our conductors. Because this is a cold motor, we're going to use this to figure out our overcurrent. So conductors, luckily for cold motors, conductors is the same. We don't change anything for cold motors. Hot motors and cold motors, conductors is the same. You use the RLC, the flaw. RLC flaw, our Rickel, our flaw, and you do the same thing. 125% for continuous duty, or the multiplier from table 27. So cold motors and hot motors, same shit. Here's an example. Single phase is the same example as before. We're just going to walk through it. What is the minimum size of AC 90 cable needed to feed this motor? Okay, we'd already figured out our flaw, our RLC, our Rickel, at 30.8. It's continuous duty, so even though it's cold, we do the same thing as with hot, 1.25%, blah, 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 blah. Okay, same shit, doesn't change. But overcurrent, now this is where stuff gets a little wild. So, overcurrent. Each ungrounded conductor of a branch circuit feeding a motor compressor, cold motor, shall be protected by an overcurrent device rated or set at not more than 50% of the locked rotor current of our LERC. Okay, that's our LERC. So when you have an overcurrent device for a cold motor, you take your flaw or the Rickel, you multiply that by 6. So it's the same question as before. We had our 30, what the hell was it, 30.8 or something, I think it was. 30.8. We found that our flaw Rickel for this motor was 30.8. For overcurrent, we have to multiply this piece of shit by 6. So we end up with a locked rotor current of 184.8 amps. Wait, oh, son of a bitch, my cats just did something upstairs. Overcurrent for a cold motor, it does not matter if it's time delay, non-time delay, or circuit breaker. Does not matter. You take your lock rotor current and you do 50% of it. 50% of your locked rotor current. So in this case, my locked rotor current was 184.8. 50% of that gives me 92.4. So again, it does not matter if it's time delay, non-time delay, circuit breaker. You take your locked rotor current, 50%, 92.4. It said cannot exceed. So you go to table 13 and you always go down. Always go down. So again, just because this shit is confusing, our FLA, for this one here, yes. So what he's mentioning is the part that's not in red. Unless such a device will not permit the cold motor to start, in which case the rating or setting shall be permitted to be increased 65%. So what we have just figured out here was based off the 50%. Our LERC, 50% gave us 92. But if the question says the motor keeps tripping, we then go 184 times 65%. Or sorry, all times, 184 times 65%. So then this would be higher. Okay? Yes, Ian, good catch. So, refresher. Our flaw and our Rickel, same thing. But if you see Rickel, it means cold motor. When we're doing conductor sizing for a cold motor, it's the same shit as with a regular hot motor. It's this times continuous duty at 1.25% or table 27. For overcurrent, you take then you take it at 65% instead. And then you do the same thing. You go to table 13 and you go down. Are we good so far? Okay. Now, overload. Woo! Overload's not the same. Overload's not the same. With cold motors, overloads don't have a service factor. So this is the actual code. The branch, circuit, insulated conductors, and control equipment for each motor compressor, cold motor, shall be provided with overload protection, complying with rules. You notice these rules are the same as hot motors, the usual motor calculations, except that we don't have service factors. Instead, we care about what we're using as an overload protection. So with a hot motor, it's service factor. With a cold motor, it's what are we using as the overload. So you do 140%. If it's anything else, such as fuses, it's 125%. So again, we don't have service factor. We take our flaw or Rickel, and if it's an overload relay, we multiply this by 140%. If it's anything other than an overload relay, you take your flaw Rickel and multiply it by 125%. That's overload for a cold motor. So how do we determine the proper size of an overload protection device that is required for a cold motor? Overload relays, it's 140% of the Rickel, same as the flaw. Other types of overload devices, such as fuses, 125% of the Rickel, same as flaw, cannot exceed, so you go down. So here's a beauty one here. A single phase cold motor is rated for 5 horsepower. This is the same question as before. What would the maximum setting of the overload relay used for this motor? We figured out before that our flaw / Rickel, 30.8. It's an overload relay, so it's 140%, which gives us 43.12 amps. When it comes to overload relays, you just leave it at 43.12. But you cannot put it any higher than that. Like you can't bump it up to 44 unless it's tripping. So if it doesn't say it's tripping, you leave it or go down. All right, now, okay, are we good on this so far? Are we good? Everyone's completely ignoring me now. Yeah. I'm trying to make this as easy as possible. I know this shit's stupid confusing, but I'm trying to make it easy. Is anyone confused? Because again, probably going to get some of these questions. Everyone's good?
Could I just say something and make it even more confusing?
Yeah, absolutely. Darren, hit me.
Hold up. Hello?
Yeah, I'm right here, bud.
Okay, if you were to take the horsepower, times it by 746, and divide it by 208, and times that by the 3-phase, you get 31. It's like the same answer.
Don't do that.
Okay.
Don't do that. You're overcomplicating it, my love. Don't do that, okay? Just use the tape. If it says the question, which it probably will, again, we'll say it's 3-phase, 600 volt, 40 horsepower, and it's an air top cooling unit. Just go and find the flaw, just like you normally would. Just go to table 44 and find your flaw, except now in your brain, because it's a cold motor, it's technically not a flaw, it's a Rickel. Again, they're the same thing, but now that you're cold motor, it's a Rickel. So just don't overcomplicate it. Just do it the normal way. Now, disconnecting means for a cold motor. Where is the disconnecting means to be located for a hot motor? Do you guys know? Where is the disconnect? 9 meter. Keep going, Ryan. You're not quite there yet. You're so close. And within sight. Correct. Cold motors, 3 meters and within sight. Okay? Hot motors, 9. Cold motors, 3 meters and within sight. So air conditioning, freezers, anything cold, 3 meters and within sight. Also, up until now, you know continuous duty is always being 125%. Well, this decides, another big FU, the disconnecting means for a cold motor at continuous duty is 115%. So you take your Rickel or your flaw, and it's 115% for your disconnecting means. Okay? So it's 3 meters and within sight, and it's 115% for continuous duty for disconnecting means. This isn't confusing at all. Now, if it asks about interrupting capacity, which you might get, interrupting capacity of the disconnecting means has to be not less than the lurk. And remember, our lurk is our Rickel times 6. So in the case of the one we were just doing, our disconnecting means would be that 30.8 times 1.15%. But our interrupting capacity would be the 180, I think it was 184, this times 6. That is not the same for a hot motor. That is not the same for a hot motor. First off, the hot motor doesn't have a log current rating for interrupting capacity. So this is very specific. Cold motor, 115. With hot motor, it's 125. For disconnecting means, hot motor is 125. Cold motors decide they just want to be a gigantic pain in the arse. What would be the off-fault current for a hot motor? I actually have no idea off the top of my head. I don't know what the interrupting capacity is. I think it has to be equal to, I think it just has to be equal to the disconnecting means for a hot motor. Yeah. So the interrupting capacity for a hot motor just has to be equal to the disconnecting means. But because this is a cold motor and the cold motor is inside all of that goo, it changes all the rules. The interrupting capacity has to be able to shut down that ridiculously large inrush current to stop the goo from doing gooey things. So we have a single phase cold motor is rated for 5 horsepower. Same questions for what minimum size of disconnect switch will be needed for this motor? Get rid of that there. Again, our Rickel, same as our flaw, 30.8. This one, again, because it's cold motor, and cold motors are stupid, it's 1.15, which gives us 35.42 amps. When it comes to overcurrent protection with motors, we always go down. When it comes to disconnect switches, we always go up. So you guys have to know, general trade knowledge, what are the sizes of disconnecting switches? What are the sizes of disconnecting switches? It's not in the code book, you're just supposed to know. There you go, Ian got it. The smallest one you can get is a 60. So it goes 60, 100, 125, 200, 225, 400, 600, 800, 1,000. That's the size of all panels, sub-panels, disconnect switches. So when it comes to fuses, circuit breakers, you go down. When it comes to disconnecting switches and panels, you go up. So because this gave us a 35.42, we would actually need a 60 amp disconnect switch for this. Again, disconnecting means for cold motor, 3 meters and within sight of the equipment. Hot motors is 9. The motor compressor bank, I highly doubt you're not going to get one of these. I know you get a regular motor bank question, but I'm almost positive there isn't a regular motor bank. So I'm not going to worry about this. It is here if you need it. And for whatever reason, if you do happen to get one of these questions on Friday and you fail, this is here if you need it. But I don't think they're giving you a cold motor bank, so you should be fine. Okay. How do we feel about cold motors? Are we good? So much better. So much better. So the only same thing between cold motors and hot motors is calculating the conductor size. That's it. Everything else is completely different. Yes, Madison, it will stay. It will absolutely stay. No problem. What if the question asks you the motor is starting under load? Because it might not say these. It might say something like the motor is starting under load. No, Ian, that is true in rush. But if the motor is starting under load, is that going to be full voltage, resistor reactor starting, or auto transformer start delta? It'd be full voltage, correct. So it might not say full voltage starting. It'll say a 3-phase, 600 volt, 50 horsepower motor is starting under load. What size of circuit breaker do we need? So you need to know that if it's starting under load, that is, when you go to table 29, that means full voltage starting. So that's the multiplier you would use. What would be for resistor starting? That's wound rotor motor sometimes. Well, that's a totally separate thing. Resistor starting would be, that's a good question. What would be a good resistor starting motor? They're never used, so I'm trying to, I can't think off the top of my head what a good example of a resistor starting motor would be, because we never freaking do it. I actually can't think of anything. Sorry. Because we always work under the assumption that things are going to be starting under full load, because that's the safest assumption to make. You always want to size everything to be worst case scenario. So if something's starting under load, you want to size your overcurrent devices for that at, say, 90 amps. If you were sizing it for resistor starting, you'd be sizing it for 60 amps. And what happens if you accidentally start under load and everything's going to blow up? So actually, I can't think of a single instance of that. Yeah. Interesting. I think this was the, yeah. Oh my God. How late are we going till today? We've only done 3.5 hours. Jesus Christ. 10 p.m. Oi. We're going till 4? I don't think so, Marcus. I don't think so. Good try. Okay, here's some motor general trade knowledge. You want these ones? Yes. Yes, Queen. Okay. A 20 horsepower, 3-phase motor draws 55 amps at 220 volts with a watt meter reading of 17,553 watts. What is the closest to the motor's power factor? Ooh. Do you guys remember how to do power factor? Watts divided by VA. That's for transformers. You're not wrong, but you're using the wrong terminology. Either way, you're not wrong. So you would use your true power, which is that one right there, divided by 54 times that. But VA, you have to be careful. VA is very specific to only transformers, not motors. Motors are measured in horsepower. Yeah. So you have to be careful. The math is the same, but it's not the same lingo. I have no idea. I'm not mathing that, but yes, you guys got it. Okay. What type of DC motor is best suited to drive a heavy load if speed regulation is not important? Series. That is correct. Series. Why series? Y series. Good torque. Shitty speed. Perfect. Oh, sorry, I'm just getting more comfortable here. What is the minimum number of overload contacts required to properly protect a 2 horsepower, 240 volt single phase capacitor start motor? None, 1, 2, or 3? Just 1. So this is another good example of too much information. Doesn't matter that it's 2 horsepower, doesn't matter that it's 240 volt, doesn't matter that it's a capacitor start. All we care about is how many phases it is. 1 overload per phase, baby. When performing a preventative maintenance check on the commutator of a large DC motor, what color of the commutating surface would indicate normal wear? Straw color, dull copper color, reddish copper color, black and blue copper color. That is correct, all copper. Congratulations. What type of protection is provided when using the field loss relay in a DC motor starter? What type of protection is provided when using the field loss relay in a DC motor starter? High speed due to low current in the shunt field, high speed due to low current in the armature winding, low speed due to low current in the shunt field, high armature current during startup. What type of protection is provided when using the field loss relay in a DC motor starter? What are we protecting against? We don't need to protect against low speed, you potatoes. We need to protect against high speed. Who said that? Need to protect against high speed. High speed. High speed. There you go. Oh, Jesus Christ. We don't need to protect. We need to protect against high speed, overly high speed. High armature current during startup. You want that. That's inrush current, you potatoes. We don't need to protect against low speed. And the shunt field comes before the armature winding. So we want to protect high speed to the shunt field. God, you guys, killing me. What is the minimum size of SAW cable required to feed a 20 horsepower, 208 volt, 3-phase pump motor installed in a sump? What do we do with this one? Minimum size of SAW cable required to feed 20 horsepower, 208. This is just a motor question, my loves. What's the first thing we ask ourselves? Is this hot or is this cold? This is hot. Second thing we're going to ask is it classy? Doesn't matter. Doesn't mention a class. We got to find our flaw. What's our flaw for 20 horsepower, 208 volt, 3-phase motor? Let me find that for me. Please. 59.4. Whoops. Does it mention continuous duty or non-continuous duty? It doesn't. So we're going to take our 59.4 and assume it's continuous duty. We're going to multiply that bad boy by 125%. And we're going to get what number, Jackie? 74. Love it. We're then going to do what? What are we going to do next? Table 19. Thank you. What is our thingy-madoodle for SAW cable? What's our insulation rating? It's taking a while to find it. I love it. I don't know off the top of my head. That might be the one with a different table. Check 11. I don't even remember what SOW stands for, to be honest with you. I don't even remember. But also, let's notice we don't have a termination temperature here. So 4-006 applies. This is less than 100 amps. So technically, 60 degrees you'd be using anyway. So at this point, it doesn't even matter because there's no termination temperature listed and it's under 100 degrees. You'd be using the 60 degree column anyway. So just do that. And you'd end up with the number 4. I feel like it's the number 4. 60 degree column for 74.25. Is it a 4? 3. Damn it, I was so close. I was so close. What type of AC motor has variable speed control characteristics? Split phase, squirrel cage, wound rotor, or synchronous? Yes, guys. See, y'all are smart. That is awesome. Wound rotor, that is true. Oh, man, so proud. What method can be used to correct armature reaction? Adding more load to the armature? Adding more copper to the armature? Shifting the brushes? Or interpoles of opposite polarity? What do we do to correct armature reaction? Marcus, if you think adding more load to a problem is a solution, maybe you need a hug. Adding more load never is a solution to a problem. If you need to correct something, adding more load is never a thing. Adding more copper, also don't do that. Please don't ever add more copper. It's a terrible idea. We're going to shift our brushes, babies. We're going to shift our brushes a little bit. Okie dokie. What is the purpose of a thermistor? Thermistor, I hardly knew her. What is the purpose of a thermistor when used in an electric motor installation? Are we using it to protect the motor? Are we using it to indicate when the temperature in the windings is too high? Acting as a cooling agent, operate only on the exterior. Love it. You guys all know what a thermistor is. We are going to use it to indicate when the temperature in the windings is too high. What causes lighting to temporarily dim when a large electric motor starts up? Starting surge of the motor, defect in the lights, voltage spike, or voltage drop? Okay, guys, the lights are dimming. The lights are dimming. Thank you, Madison. Thank you, Marcus. A voltage spike is going to cause the lights to go brighter. Yeah, flipping electricians. Voltage drop causes the lights to go dim. Oh, you guys are going to do so well on Friday. It's going to be amazing. You already know how to do that one. That one's fine. How does a PLC communicate with the control field devices? Telephone line, input-output rack, hardwired control panel, communications lines, and interconnecting appropriate equipment. Let's read this again. How does a PLC system communicate with the control field devices? Control field devices. How does it communicate? Communicate. There we go. Communications lines. Communications lines. How does it communicate with the control field devices? Interconnecting and communications lines. Okay. An establishment, a fine establishment, requires that a conveyor system length be increased. How are the new stop buttons to be installed? In parallel with the conveyor, in series with the conveyor, in parallel with existing stop buttons, in series with existing stop buttons. Yeah, babies, stop buttons are always in series. What is the purpose of using the capacitor on a capacitor start motor? Do we use it to correct power factor, reduce line current, increase torque, reduce resistance? What do we use a capacitor for capacitor start motor? What does a capacitor do? It wakes up in the morning, kisses its wife on the cheek, grabs its lunch, and says, "Goodbye, dear. Today I'm off to go to go reduce my line current." Capacitor is full of voltage. What do you do when you have too much inductance? You add some capacitance. When you have too much inductance, you add some capacitance. So the capacitor is there to reduce the line current. When connecting two generators in parallel to supply an electrical system, what items must be synchronized? Voltage, frequency, speed, frequency, phase sequence, voltage. Oh, the answer's already there. My bad. Frequency, phase sequence, voltage. Whoops, I forgot to take that out. Haha. I'll give you that one. But either way, in this question, again, it's parallel. So in parallel, what stays the same? Voltage. So obviously current is out and current in this one is out because again, only 3 rules. And in a parallel rules, voltage stays the same. And these are the only 2 that have voltage. And you don't synchronize your speed. That doesn't make any sense. Oh. Do you guys even need me? Can you just do this on your own? Lord. Oh. Here, Nathan, you do number 16. You teach that one. Nathan, where are you? You do number 16. Teach it. Come on. Am I even saying your name right? Is it Nathan? Yeah, nice. You know what? I gotta ask. What is your name? It's not Greek. What is your name? Oh, is it Indian? It's a very unusual last name, Indian-wise. I've never seen that before. Huh. Table D13. That's gonna be a problem, Rodrigo. D13 is not gonna give you much help with this one. Sorry, I think I'm getting mean. I might need some sugar. What is the minimum size of Tech 90 cable required to supply a 150 horsepower, 6-volt, 3-phase, totally enclosed, fan-cooled Class F motor? Love all of it. You can do 2 things. You can either do it the hard way, or you can go to table 16 and look up. Oh, you can't use table D16. Doesn't tell you what type of motor it is. Because you have to know whether it's squirrel cage or whatever. So you have to do it the hard way. A 2 horsepower 3-phase AC fan motor rated at 208 volts will not start using the standard rated size of circuit breaker. What is the maximum rating of a 3-pole circuit breaker that can be used? Ooh, that's a good one. Actually, hold on. I don't know how to do this. 2 horsepower 3-phase AC. Oh! Is that hot or is that cold? It's an AC fan motor. I feel like that's hot because it's just the fan. It's not the actual AC itself. Yeah, that was a tricky one. So that's a hot motor. Okay. So we're going to find our flaw. What's my flaw? I actually have no idea how to do this. So we're going to do this together. What's my flaw? For a 2 horsepower, 3-phase, 208. And don't forget, you have to multiply 208 by something, I think. 7.5. Continuous duty, what does that give me? 9? Now, hold on. What'd you say it was, 7.5? I think this might be a cold motor. Give me a second. Actually, I am doing this as if I've never done it before. 7.5 times 6. Whoa, try that again. Jesus. 7.5 times 6 is 45 divided by 2. That is correct. This is a cold motor. Oh, my bad. AC, it's a cold motor. So my flaw, or my Rickle, is 7.5. It's asking about overcurrent, which means I got to turn this into my lurk. I have to multiply that by 6, which gives me, I already forgot, 45 amps. I have to take 50% of that, which gives me 22.5. We only do 50%, Jason. We do 50% unless it's tripping, and then you go up to 65. So it gives me 22.5, and then that gives me a 20 amp breaker. The 3-poledness doesn't matter in this case. Oh, hold on a sec. Will not start. That's right. Thank you. So it will not start. So you would go up to a 25. You just go up to the next one. I guess the 65. Thank you, Jason. My bad. So it would be the 65. So what is 20, 45? Hold on. 45 times 0.65 gives me 29.25. So yes, then we would go down to 25. Oh my God, I'm so proud of you guys. I screwed this up, but I did such a good job teaching about cold motors. You caught that. Oh my God. Jason, I'm so proud of you. Oh my God. See, I would have gotten that wrong. You practiced them before. Oh, well, fine then. Fuck you. Okay. Take the compliment, dick. I'm just kidding. Sorry. But I helped. Okay. A variable frequency drive is tripping the overload protection upon startup of the motor. What should be done to correct this problem? The variable frequency drive, or VFD, if you will, is tripping the overload, not the overcurrent, the overload. Upon startup, what should we do to correct this problem? Oversize the overloads, increase the startup time, oversize the fuses, increase the motor size. Well, increasing the motor size doesn't make any sense. Thanks for playing, Max. And again, this is overload. Overload doesn't have anything to do with overcurrents, the fuses. And we never, ever, ever oversize the overloads. Ever. So we are left with increase the start time. Sorry, I dropped my tablet. Increase the start time. Oops, sorry. Oh, we already did that one. The rotor of an induction run motor rotates at what speed? Synchronous speed plus slip, minus slip, stator speed. Correct, minus slip. Good job. Can we take a quick break? It's been an hour. Is that okay? Yeah, thank you. Oh, right. Oh, yeah, I'm gonna get cut off at 12. Oh, yeah, we got to switch over to the new one anyway. Thank you, Madison. I forgot about that. Okay, so we're all gonna log out of this, and then we have to log into the new one because I forgot. Yeah, I'm gonna cut off at 12. So I'm gonna end this meeting, and then everybody go log into the other one in like 10 minutes. Okay? Sounds good. Love you all. How are we doing? How are we doing? Mohammed, where'd you come from? Hungry for knowledge. Oh, bless your heart. Bless your heart. Oh, my brain is starting to not brain anymore. Not gonna lie. It's exhausting being this smart. Okay. grab a beer. I'd love to. I would love to, but I have to take my daughter to gymnastics later. So unfortunately, I have to be sober for. Oh no, actually, maybe the hubby can drive. Okay. Okay. Well, we'll consider it. We'll consider it. Actually. Okay. Yes, I know it's a shock. Somebody loves me, right? I'm always surprised too. People are like, "Wait, you managed to find a guy to put up with you?" I'm just as surprised as you are. Okay. Anyway, wiring diagrams. How do we feel about these? Because you're gonna have like at least 5. At least 5. Better than code. Code's fine. You're fine. All right, so my best advice for control wiring diagrams is look for what you know and break it down into manageable chunkies. Let's do some examples. Oh, look, this is the type you're going to see on the actual C of Q, these bad boys. And remember what I said about how it all depends on which test you get. So 2 of the tests are going to ask you about that. 2 of the tests are going to ask you about that. So it'll say refer to diagram 3, blah, 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 at point X. What happens if the wire breaks at point X? What happens if the wire breaks at point Y? So in order to understand what would happen, you kind of have to get an overall feel for the wiring diagram itself. So I'm looking at this stupid thing. Is there anything here that I recognize? What do I know? Well, right off the bat, we look at the top, and this is just a regular, everyday, average 3-phase. So if the question doesn't ask about supply or 3-phase, you can actually just ignore it. Because all of this down here is the control circuit. The only reason you have this up here is to confuse you. So unless it asks about something to do with the supply, literally just ignore it. Come on, load up. There we go. Is there anything else that I recognize? This right here is just a basic stop-start. This is just a basic stop-start, oops, with 2 buttons. We have a forward and reverse. So all we see here is a forward and reverse, 2 buttons. Now, we got some extra stuff though. Of course there is. There's always extra stuff. What's this happy crappy down here? We got some float switches. Some lovely float switches. When we're looking at this too, you want to pay, and I'm actually going to go back to the other one, close attention to, we have 2 options. We have manual going on or auto. So the question is, because this looks different, remember what I said about look for kind of what you do know, but also look for what is unusual. This is what is unusual about this one. There's a manual and an auto. So chances are this stupid thing is going to ask us about the auto feature. So we'll just follow the auto feature down, and we notice that the auto feature is dependent on these lovely float switches down here. The manual is dependent on all of our buttons. Keep going, keep going, keep going, keep going, keep going. Come on, there we go. So a significant aspect of wiring diagrams is knowing what the symbols are, what they're used for, and understanding what they do. We kind of covered that yesterday. So understanding that normally open, normally closed, timed open, timed close, or on delay, off delay, limit, flow, temperature, pressure. Again, friendly reminder that our control relays control all of the contacts that are associated with that. And again, friendly reminder that when we look at this like this, it's in its resting state. So when it's in its resting state, it means it has not been energized yet. It is not until it's energized that the magic starts to happen. Again, if you guys are understanding this, then I don't have to walk all the way through it. Here's the, unless it asks for supply, this is useless, blah, blah, blah. Trying to find the actual one I want here. So this basically just walks you through how to understand the wire diagram. I'm looking for one specific one here. So the question you're going to get based off of that, oh, sorry, this one here is going to be point X or point Y. So essentially, Question says, what happens to this circuit if the wire breaks at point X? What happens to this circuit if the wire breaks at point Y? So again, you have to understand overall what this means. So let's do X first. If the wire breaks at point X, this one's actually fairly simple. If it breaks at point X right there, one, it means that this holding contact is no longer going to be able to be used in the manual setting. And it means that CR1 and the float switch, it will also not be able to go into forward based off the auto feature either. So if the wire breaks at point X, you cannot use the forward feature unless you push the button, but the auto feature will not work at all. Because if you notice, CR1 here, if it breaks, it doesn't matter if this closes. If it breaks, the auto feature will not work. So what happens if the wire breaks at point Y right here? It's the exact same thing, except now it's reverse. The motor will go in forward with both the manual and the auto. It will only go in reverse. Oh, sorry, it'll go in reverse manual. It will not go in reverse for auto, because if it breaks here, then this won't work. Oh my God. Yeah, my brain's getting real stupid. I'm slowing down. Did that make any sense? Does that make sense? I'm sorry. I'm getting real. I got to find my coffee. Hold on. Oh my God. Where's my coffee? There it is. It's freaking freezing cold, but I'm going to drink it anyway. Oh, shit. Yeah, it's all right. That is a good 5-hour-old coffee. Okay. Can I say that one more time? Can I say what one more time? That my coffee was good? Oh, okay. So again, depending on what test you get, it's either going to ask about X or Y. Yeah, no, me too. We already did X. With Y, if the wire breaks at point Y, it won't affect the manual at all. Because if you notice, you follow the yellow brick road, and our holding contact will still work as well. So with Y, manual for the reverse will be just fine. If it breaks at point Y, that means that reverse will not work under auto. Everything will work. Forward will revert for auto, and for manual, reverse will work just fine for manual, but it will not work for auto. With the wire breaking at point X, forward will not work for auto because it's connected to CR1 down here. So it's broken, it'll stop there. And forward will not, the holding contact will not work. So forward will only work if you're constantly holding the button down. So you're going to get, if you get something like this, both of the questions are going to ask basically what I just explained there. When will the forward work? When will the reverse work? Yada, yada, depending on whether you're looking at X or Y. Here's another one. Again, let's do this. Is there anything here that I recognize? Yeah, I see a whole lot of stop starts. So at the very top, I see just a regular stop start circuit with a light attached to it. Beautiful. Down here, I see another stop start attached. Lovely. I got a whole bunch of freaking motor coils down here, and I got some lights. All right. Beauty. Now, this one, the trick is, you see over here, nothing will work down line until that contact is closed. That contact is associated with CR1. So nothing down here will work unless this is going. So this is the trick. This is what the question is going to be about. Because this right here, that's the unusual thing. That's the thing that sticks out. In the last one, the thing that stuck out was this. So you know the question is going to be something to do with the manual and the auto, because that was what is unusual. This one, what's unusual is that stupid little thing right there. So it's telling you right off the bat that nothing will work under here until you start, motor start This guy right here. Once this motor starts, that closes, and now all the magic happens down. Do we see any X's and Y's? So because we don't see any X's and Y's in this, that means that it's not going to do the whole what happens if a wire breaks. You can almost guarantee if you get a question like this, and there's no X's and Y's, look for that weird thing that you don't recognize. Again, it'll be this one. So we see that everything downstream can't work until this is going. We see that CR2 cannot be engaged until our pressure switch is up. Once the pressure switch is up, CR2 is energized, which means now we're going to look with all the associated ones. That closes, that closes. CR2 closes, M1 starts. Awesome. So we're going to look for anything associated with M1. Do we see anything associated with M1? We don't. So guess what? M1 doesn't mean sweet patootie all. It's got nothing. We see that M2 is energized, so we're going to look for things that are associated with M2. Oh, look, right here. Oh, I missed crossing that one off. Right here. So that's going to open, which means when M2 is energized, that's going to open and the light's going to turn off. Hey, I bet you this question is going to be asking about the lights. I bet you it's going to say, when will PL3 light turn off? And then the answers are going to give you a, I don't know how to explain it. They're going to give you a, this has to happen, this has to happen. Answer B, this, oh my God, what's the word I'm looking for? Sequence of events. So each of the answers is going to give you a sequence of events as to when PL3 turns off or when PL2 turns off. So in this case, let's pretend the question is, when will light PL2 turn off? PL2 will turn off after CR1 has been energized, CR2 has been energized, and M2 has been energized. Once those three things have been energized, the light PL2 will turn off. So I guarantee you that's going to be the question. The other question might be, when will light PL3 turn off? Same sequence of events, except it's going to, CR1 has to be energized. CR2 has to be, no, it doesn't. Hold on. Nope. CR3 needs to be energized. And then once CR3 is energized, then PL3 light turns off. So when you, again, when you see these, look for what you know. Okay, stop, start, stop, start. Oh, there's some lights, bunch of coils. Awesome. And then look for the thing. Look for that one thing. Last one was the manual auto. This one is this guy right here. And I think I have one more. Hold on. Doot, 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 doot. Yeah, look at this one. Oh, this bad boy here. First thing, what do we see? What do we recognize? What do we acknowledge? We have a basic forward reverse right here. Beautiful. We've got kind of a basic forward reverse right here. We've got one button that controls motor T, and we have 3 buttons that control motor, I think it's a B. And then down here, we have a crap ton of lights. Red, green, yellow, amber. Hey, guess what? Let's look for the trick. I bet you the trick in this one is going to be this stupid looking thing up here. Because what the shit is that? Before anything can happen, notice the limit switch, but the big thing is, what's the stupid thing in this one is that. So much like the manual auto one, this one has 2 different ways of going about it. Oh my God, there's some dogs fighting outside my window. Should yell at them. When it's in the up, hold on, let me actually zoom in here. When it's in the up position, this is when you can do the forward and reverse, as you guys can see right here. Nothing else needs to happen in order for these, for motor T5, for forward and reverse to happen. Right here. The only way motor T5 forward and reverse can work any other way is based off of a time delay. If this is pushed down, now we have a time delay problem. So this sounds to me like this is going to be a question that's going to be based off of what's the order of operations again? So it's basically what's going to happen. So with this one, in order for this to be down here, the time delay has to work. Oh, look, in order for the time delay to work, we need to flow pressure. But look at these stupid little guys. Everything downstream cannot work until the forward or reverse is on. So motor T5 has to be on before anything else can happen. Anything else can happen. Our timing delay, look at that stupid thing, has to be on before anything else can happen. So the order of operations is motor T5 has to be on and the time delay has to have been engaged. Once that happens, all this other crap stuff, sorry. So what would be the order of operations for the amber light to go off? Because we're noticing right here, since these are all closed, the red, green, yellow, and amber lights are all currently on until this starts happening. So I'm asking you guys, pretending like you're paying attention, what is the order of operations in order for the amber light to go off? And keep it simple. Shrink it down a little bit. There we go. Go based off the motors. T5, T6B, T6C, T6D. Motor T5 on, correct. Everything always has to start with motor T5 on. Don't forget, yep, time delay. So everything has to start with motor T5 on, then time delay. And then we notice T6B. We look at A is related to B. This is T6B. So as soon as motor T6B is engaged, amber light turns off. Beautiful. All right, what in order to get the green light to turn off? Well, so we don't have to worry about the HDA down in this case, Ian, because it doesn't matter. That's there to fuck with you. We just need to know, based on this part right here, that in order for any of this crap to work, motor T5 has to be on and the time delay has to be on. So none of this matters here, unless like the specific question I'm asking. So right now, what do I have to do in order to have the green light turn off? Green light turn off. Motor T5 on, yes. In reverse, beautiful. Green's pretty easy. It's only related to this. Now let's say, what would be the order of operations for the lights to all turn off? So which light would go off first, second, third, and fourth? Which light would go off first? You're both right. It depends. It's either going to be red or green. It's either going to be forward or reverse. So either the red or the green is going to turn off first. What's the next one that's going to turn off? Yellow, because it's based off the time. And then what's the next one? Then amber, because it's based off of motor 6B. Or sorry. Nope, sorry, hold on. Sorry, this B, motor T6D, because that's the B coil right there. So motor T6D. Now, what's the order of operations in order for motor T6D to go on? Motor T6D has to go on. What's the order of operations for motors? Yeah, we're always going to start with motor T5 on, time delay, and then T6C has to go on. You missed one. It has to be T5, 6B, 6C, and then 6D. This 5 has to go on, time delay. Once T is on, that closes, that closes, that closes. This one cannot turn on until that's on. This one cannot turn on until that's on. So now my W's on, whatever, T6C. So now that one can turn on. So it has to go in order like that, okay? Those are the questions they're going to ask you based off of this shit. Does this seem like it's something that's going to take you longer than 2 minutes to figure out? More than likely, yes. Let's keep in mind, you're going to be nervous. You're going to be scared that you're going to make a stupid mistake. You're going to be overthinking. You're going to get distracted. You have to pee, whatever. It's not going to be all nice and relaxed like we are here. Do not try to do this in the beginning. When you are sorting through your shit, like I've mentioned, can you do these? Absolutely. Do not try to do them right away. I can guarantee you, you cannot do it in under 2 minutes. So you're going to take the question and you're going to put it in the happy face column. You're going to then wait until the end and then you're going to go back to it later. There is no way in hell you are going to be able to bang out 5 of these in under 2 minutes. Again, it seems like you can, but we're in a really relaxed state right now. You guys are going to be an absolute nervous wreck when you go into your exam on Friday. It's a really big deal, totally understandable. For as much as I tell you to relax and just don't try to pass it, just try to do it, none of you are going to listen to me. Every single one of you is going to be like, I'm going to get an 80. I'm going to be the smartest person ever. I keep telling, don't do that. Just go in and try to do it. Don't try to pass, just try to do it. None of you are going to listen to me though. Put it in that little column there. Worry about it later. Whoops, sorry, I didn't make you pukey. It's just 100. I don't know why that says 150. It's 100 questions. Nothing's changed. It's always been 100 questions. You didn't hear what part, Ian? What part exactly? About don't try to pass? Where were you yesterday? Yeah, don't try to pass, my dude. Just go in on Friday with the expectation of like, great, yeah, do your best, but don't try to pass. Good God, no. You can't hear me right now. That's a you problem because I'm okay. Oh, whoop, I dropped that too. Okay. Well, I've officially run out of all things that I was planning on teaching you. I don't think I look like you, Lucas Godberson. So that would be problematic. I don't think I look anything like you. I'm probably 3 times your age and shorter. I don't know, Madison, are you a 44-year-old grouchy white lady with short hair and covered in tattoos? Sit here chain smoking and drink coffee. Is that you, Madison? I know, Max. I know you're trying to pass. I know. But I'm telling you, it's not that you guys are not smart or don't understand code or don't understand anything. It's timing. It is essentially impossible to be able to 2 minutes per question. Like, that's insane. The only reason I was able to do it as well and as quickly as I did is because I've gone to university, I'm older, I'm ridiculously good at taking tests. I'm not sure if they still do. You'd have to call them, but Peterborough, Kingston, and Barrie, I think. Also, if you do fail on Friday, again, no shame whatsoever, but when you rebook, don't tell anybody about it. Like, don't even tell your boss. Just say you have a doctor's appointment. Don't tell anybody. If you're rebooking, don't tell anybody because you're going to be getting a whole lot of, did you pass? Did you pass? Especially from your boss. As long as you pass within the year, it's fine. Nobody needs to know that you took 3 or 4 times. especially your boss and your coworkers. None of them need to know that you had to write 2, 3, 4, 5 times. So do not tell anybody when you book your test. You just have a doctor's appointment. You can't make it in on Thursday. Like, that is the best piece of advice I could give you, because it's super fucking stressful when your coworkers and your boss know, especially when they know like you failed 2 or 3 times. It's very disheartening. Anyway, yeah, I've read through all the stuff I was going to teach you guys. So I don't know. What else do you need from me? What else would you need? What is your tutor course info? Oh, my email. jherrick@live.ca. Okay, so the other thing I guess I should mention, that's a period, is now it all depends on you. Let's work under the assumption that you guys, don't do well on Friday, and that's fine. You all might pass, I don't know, but let's work under the assumption that some of you are going to fail, and you want to get some tutoring. You have 2 options. You can do one of those, I think it's like $600 or $900 or whatever, and do like the weekend testing thing, or like, you guys know what I'm talking about, right? Like weekend courses or whatever, and they're ridiculously expensive. Yeah. Or you can get a private tutor. Me personally, I opt more towards the private tutor, because again, when you fail it, you're going to look at the Skilled Trades Ontario and you're going to see that you really sucked, let's say the transformer section. You did pretty okay in everything else, but the transformer section really screwed you. It seems a waste of money to pay $600 to do a week-long course or weekend courses already covering things that you're okay with, when you only need help with transformers, or you only need help specifically with motor code, or you only need help with wiring diagrams. So you can spend $600 and go over all the stuff before, that's fine. Or you can spend like $120, get 2 hours of the private tutor, and just go over the stuff that you specifically need help with. Again, you don't have to go with me. I'm not suggesting that. I'm not trying to, whatever that word is I'm looking for. There are other tutors out there. You just have to Google CFQ 309A prep tutors. There are a bunch out there. We're all different wages. Some are $40. I think there's one guy out there who's like $100 an hour. I would never pay that, but that's me. I'm 60. Like, we're kind of all over the map when it comes to that. There's no standard for it. Conduit and box fill, eh? Okay, what specifically do you need for conduit and box fill? Hold on a second. I have the PowerPoints here. Download. And download. Some examples. Sure we can. Sure, friend. Just let me upload my PowerPoints here. Now I want to point out, these are not the best of my PowerPoints, only because I knew they were changing it in the new code book, which they have. So I have to redo my fucking PowerPoints, because they changed it. Okay, box fill. All right, so this is where it gets fun. What do we count in a box? We only count if they enter or exit when it comes to wires. That's it. Enter or exit. That's it. Moret, the CFQ is not going to call them Morets, though. It's going to call it, a wire nut or a connector, wire connector. They're only counted in pairs. So 2 Morets equals 1 wire. 3 Morets still equals 1 wire. 4 Morets equals 2 wires. 5 Morets still equals 2 wires. So we only count them in pairs. Does that extra Moret take up space? Yes, but they don't care. We never count the grounds unless they are insulated. If the grounds are insulated, we count them as a conductor. If they are not insulated, we don't count grounds. Okay. When it comes to devices, each switch we're going to pretend is two conductors. Each receptacle we're going to pretend is two conductors. And each fixture, stud, or hickey, those are for lights, we're going to pretend is one conductor. So, again, they have to enter or exit. If the conductor enters and exits, we only count it as one. If it just travels straight through, it's only one. So we've got a black, a red, and a white. This only counts as three. It just goes straight through. This, we have three that enter and we have three that exit. So we have three coming in, three leaving. That's six conductors. We have three morettes. We only count them in pairs, so we ignore this one. Three in, three out, and we're going to pretend this one is another one. So when we're considering box fill, this one has 7 conductors in it. We do not count pigtails. They do not enter. They do not exit. We do not count pigtails. We do not count them. Do they take up space? Yeah. We still don't count them. So look at this one right here. What size of box do we need with all of this? How many conductors do we have? We've got 3 going straight through, 3 coming in, 3 leaving. So that's 9. And then we have 3 morettes, but again, we only count them in pairs, so we ignore this one. This one counts as 1, so this is 10. If it's a 10 number 8s, we then go to table 23. We look up what size of square box, octagonal, whatever type of box they're telling you. And then you look, you guys know how to use the chart, so you're fine there. Now this is a little more complicated. It looks messy. But again, we only count them if they're entering or exiting. So don't pay attention to any of this shit. Just look at the pipes. There's only 2 entering and only 2 exiting. That's it. Ignore all of this other shit. We only count them if they enter or exit. Look at the pipes. We have 2 entering. We have 2 exiting. We don't count that because it's that ground right there. We actually don't count that because it's not entering or exiting. And if it was bare, we wouldn't count it anyway. Now, we have 1 pair of morettes, so that counts as 1. Our switch counts as 2, and our receptacle counts as 2. So we go 2, 4, 6, 8, 9. That's it, 9. Now, these are 9 number 12s. You would go to table 23, and depending on what octagon, square, triangle, whatever type of box, you know how to do that. What do we do when they're different sizes? When they're different sizes, now we can't just randomly add things because they're not all number 12, they're not all number 8. That's when we have to use table 22. Again, they only count if they're entering or exiting. So we're going to do the same thing. We look at the conduit. We don't look at the wires inside the box. Just look at the conduit. We have 2, oops, I gotta turn this part on. We have 2 number 8s entering. And we have 1, 2, 3, 4 number 12s. So don't look at this shit. Just look at the conduit. So you have 2 number 8s and 4 number 12s. We go to table 22 and we look up how much space does 1 number 8 take up. 1 number 8 takes up 45.1 mils. So there's 2 of them. We multiply that by 2. How much space does 1 number 12 take up? 1 number 12 takes up 28.7. There's 4 of them, so we take 28.7 and multiply it by 4. But what about morettes? What about switches? What if there was a fixture stud or an outlet? When you have extra crap jammed in there, what do you do with the mils? How do you factor that in? What you do is you pretend it's the bigger wire. So in this case, because our number 8 is bigger than our number 12, we're going to pretend this pair of morettes, which we're going to pretend is one wire, we're going to pretend it's one of the bigger wires. So instead of having 2 number 8s, we're going to pretend we have 3. Let's pretend like this was a square boss and we had a switch in it as well. A switch, we pretend is 2 wires, but because there's different size wires, we always pretend it's the 2 bigger wires. So we would pretend there was an extra 2 number 8s there. We don't actually have a switch in this one. We just have this stuff. So we pretend this is a number 8. So instead of doing 2 number 8s, we're going to do 3 number 8s. So 45.1 times 3 number 8s are 12 times our 4 number 12s. We add our milliliters together, which gives us 250.1. We then go to table 23, and it says what size of octagon, square, whatever, and you look and you find which one will hold 250 milliliters. What about bigger than number 6 wires? Where do you get that mil? Those don't go, that's not considered box fill at that point. Number 6 is because that's now considered industrial. There's actually no rules on that. We only do box fill for housing residential sizes. So it generally won't go any bigger than a number 8. Anything bigger than a number 8, yeah, there's really no rules. You can jam them in because now you just have to get a junction box. So I don't think there's anything in your house that requires anything bigger than a number 6 or a number 8 anyway. Yeah, there's nothing in your house that requires anything bigger than an 8. Ow. Oh, yeah. Hold on, Madison. Hold on. All right. We're going to do conduit fill and then PowerPoint 16. Which PowerPoint are you talking about on distribution? Where are you looking? PowerPoint 16 on distribution. Where is that? Where's PowerPoint 16? Help me out. I don't like the shared in PowerPoint, so I have no idea where anything is. I'm required to give them to you. I know content PowerPoint. Which one? Oh, just the one called PowerPoints? Sorry. Which one? Distribution? Oh, okay. I'll download it. We'll do conduit fill first, and then we'll do that one. So conduit fill is exactly like box fill in that it depends on if they're the same size or if they're not the same size. Now, you guys have the option of using, table 10. I don't advise it. I would just use table 6 for everything. It's a lot easier. This PowerPoint does walk you through how to use table 10 if you want. But frankly, you can just use 6 for everything. So for same size conductors, again, you absolutely need to make sure you're on the right table, A, B, C, D, E, F, Q, whatever, based on whether it's unjacketed and what the voltage is, because it does very much change. The conduit fill is so unbelievably easy. 3 conductors, we have got 3 RW90 XLPE unjacketed, 600 volt, number 6, and rigid metal conduit. What size? You just go to 6A, and then you look up number 6, and then you go to 3. And it tells you it's 113.81. You then go to table 8, make sure you're at 40% fill, and then you go to table 9G and you look in rigid conduit, which gives you 21 trade size. If they're different size conductors, again, this does do the number 10. You can just do 6, it's the same. So, oops, hold on a second. Let's pretend, just ignore all this. We've got 1, 2, 3, 4 number 8s. And we have 1, 2, 3, 4, 5, 6. 6 number 12s. Just go to table 6. This is 6A. Go to table 6A. Look up how much space 4 number 8s take up. Look up how much space 6 number 12s take up. Add them together. And then you have your answer. And then again, you go to table 8 to double check what your fill is. It's going to say 40%. And then you go to table 9G because 9G is your fill percentage, 40%. And then if it says EMT, you look in that column. It's not it's actually a lot easier than box fill. Distribution. Okay, no, I've never seen this PowerPoint. Because again, I'm not a fan of Sheridan. So let's see what it's about to say here. Okay, distribution 3 wires. If pulling a ground, we always count for a conduit fill though, right? Absolutely not. You should never have a ground in conduit. You should never have a ground in conduit, ever. Ever. Still don't count it. That's a bond. Yep. You bond the outside. You should never put them in. Then no, they don't count. Oh, sorry, Madison. Where the PowerPoints under the content? No, they're not. So if you go to content and you go all the way down to the bottom where it says extra info, that folder is mine. None of this is mine. I'm not a fan of Sheridan stuff. Don't tell them I said that. No, go to content, go to the folder said extra info. Those 40 PowerPoints are mine. None of these are. Yeah. So like I've never seen this before in my life. So I have no idea what I'm about to jump into here. I don't even know. Okay, what is this? It's 2 batteries. Okay, so. Oh, you are absolutely not going to get any of these questions. Jesus. It's asking, what the fuck is it asking? This is asking what are the amps on this line, what are the amps on this line, and what would be the unbalanced load going through the neutral. So we have 2 batteries that are wired in parallel. Sorry, series. They're wired in series because it's 24 VDC, 1000 milliamp hours. Yeah, and then you have to do a shit ton of math, like the upside down formula stuff. You won't get this at all. Oh, was that it? That's it. Okay, that was it. That's the PowerPoint apparently. We did do service calculations. We already talked about that, unless you mean something else. That's okay. What type of service calculations are you referring to, friend? Sorry, I'm just waiting for. Oh, I don't think. No, you're not going to get a question based on that. That's so insanely complicated. It takes like an hour to do an apartment building with additional lighting loads. You will not get a question on that. You will get a question based on, let's see, you have an 8-unit apartment building. What demand factor do you use for the 8th apartment? What percentage demand do you use for the 8th apartment? And I think it's 40% or 25. Yeah, I don't fucking remember. That's about it. You're not definitely no, because even the one I mentioned, they give you one ridiculously insane house service calc. Immediately put it in the you'll do it later because it's going to take you 5 or 10 minutes. And again, it's only worth 1 point. So it's like this ridiculously long one. And I think it asks, crap, what is it? It's, hold on. You have a house with a basic demand load of, I don't know, I'm just making numbers here, 9,600 watts with an 8 kilowatt fridge, stove, 5 kilowatt AC, interlocked with 16 kilowatt baseboard heating. and 2 kilowatt dishwasher, and let's do 1.7 kilowatt dryer. And the question will say, what are total demand watts? No, you're not confirmed to start at 8 a.m. tomorrow. Sorry, Brent couldn't do it. So anyway, this is one of the questions they're going to give you. Now, can you do it? Sure. Is it going to take you longer than 2 minutes? Probably. So again, just put it into the little happy face column. You can deal with it later. But this is a question you very well could get. Again, remember, this one's only worth 1 point. Don't spend 20 minutes doing it. Go do all the easy ones first and then come back to these ones. Because again, it's really going to suck if you spend 20 minutes on this one and then you run out of time. And during that time, you could have answered a bunch of easy ones. So yeah, this one is going to give you a bunch of crap, and then it's going to say, what are the total demand watts? And guess what? The trick, because they got to trick you, the trick on this one is the baseboard heating. That's where they're going to trick you. Because again, if it's hot, it uses a lot, it's 100%, but it's 100% up to 10 kilowatts and then 75% after 10,000. So that's where they're going to get you right there. The fact that the AC and the baseboard are interlocked, that's kind of a trick. And the dishwasher is 1.2. So technically it's not an additional load. So you just have to remember all that stupid stuff. I'm sorry, I didn't make the test. I didn't make the test, man. And I agree with you. I 100% agree with you. Like, I call for an electrician because I need someone to come do electrical things in my house, and you show up and I say to you, hey, how do you clean the sensor on a boiler? And you're like, I don't know. I'm like, then you can't be here. You're clearly not a good electrician. Like, no. Whether or not you're a good electrician has no, it's got no bearing on whether or not you're like, honest to God, do you guys know how to clean the sensor on a boiler? Because that's a question you could get. Cleaning the flame sensor on a boiler, you use wire wool. Wire wool. Hey, do you guys happen to know what the color of light on a glue pot is? Because that's a question you could get. No, it's blue. The color of light on a glue pot is blue. The fact that you don't know this means you're a terrible electrician. No, it doesn't. See, that's what I'm saying. Is the test bullshit? Abso-freaking-lutely. Absolutely. And I think what really pisses me off, pardon my French, is when I was an apprentice walking around and all of these old freaking boomers acting like king shit of turd hell and being so patronizing and talking down to me and all this other stuff. And I'm like, you didn't even have to take a CFQ. You've been an electrician for so long that they literally didn't even have a CFQ. You just showed up with a penis and they hired you. Those were the qualifications you had. So don't act like you're better than everybody. Did I also work at Durkheim? I have not. I have not. And Beverly and Madison have gotten probably the most patronizing, condescending, like, I don't know where they work, but being women, the amount of men that have treated me like absolute garbage because apparently because I own a uterus, I'm stupid and I couldn't possibly know how to do anything. I've been treated like that for my entire apprenticeship. Sweetie, honey, no. What are you doing? And you're like, I know what I'm doing. No, honey, no. And they touch you. They touch your back. They touch your shoulder. And it's like, don't touch me, Gary. You smell like ass sweat. Anyway, sorry. They are so gross. Like, look at me. And what makes you think that I want a sweaty, overweight, balding, like gross man who's got broken blood vessels in his nose from drinking too much and half rotted teeth. Like, look at me. Nobody wants that. Stop flirting with me. Brag. Anyway, I teach now, so I don't really have to worry about it as much, which is kind of nice. But the amount of sexual harassment, sexual assault, like just the touching, the grabbing of the boobs, it's been so good. I love teaching. I do not have to deal with any of it anymore. This generation is growing up with TikTok. That is true. It is true. So anyway, all of that to say, don't let anyone make you feel bad for failing at all, because chances are they didn't even have to write one. If they're over the age of 50, they didn't even have to write one. So if they're like, oh, it took you 4 times to pass or whatever, be like, they didn't even have to. They literally showed up out of high school with a penis and they went, you're hired. So, yeah. I'm not a fan of mediocre white men. I'm sorry. I get in trouble a lot for going on rants about mediocre white men. Oh, I apologize. They do suck. They really do. Oh my God, 5 hours, eh? Look at us. Look at me. I'm not going to lie. You're probably going to get maybe another hour out of me because my throat's freaking killing me right now. And I smell bad. Smell so bad. Okay, what else do you need from me? What else do you want from me? Again, friendly reminder, tomorrow you are starting at 12 with Brent because he said he can't start any earlier than that. And again, I believe all day tomorrow and all day Thursday, you're just doing questions. Just questions. Do I offer discounts? What am I, freaking Walmart? Do I offer discounts? I don't know you. Are we friends? Am I friends with your mom? I'm just kidding. Jackie, generally, I don't offer discounts for the first 2 hours, but if you need anything more than after 2 hours, then yes, I do offer discounts. You could do the coffee runs. No, I do it online. Just like this. I'm in Peterborough, guys. Well, I'm not in Peterborough, but I'm in a little village outside of Peterborough. I'm not driving all the way to friggin' Sheridan to Tudor. God, no. That's what I love about Sheridan. Everything's online. I'm literally sitting here in my pajamas. I'm a sloppy mess. Hey, who's in charge of the apprenticeship? Who's in charge of the apprenticeship? Dan, right. Can you guys, if you like me, whatever, can you do me a favor and email Dan Hammond and just say that I'm awesome? I would really appreciate that. Just because, like, don't mention the swearing and don't mention the thick and juicy thing. Yeah, like, don't mention those things. But the only times they ever hear from students is when they're complaining, and it would just be nice to even that out with a couple of nice emails once in a while. So if you can prove to me that you sent a really good email, I would absolutely give you a discount. Absolutely. I think that might be extortion, but you know what? Screw it. It's fine. Oh, right. The other thing I meant to mention, you guys, what is the general age of you guys? Are you all like 25 or 30 or what? Okay, so a little bit older. Okay, so not so much Jackie, sorry bud, because you're super young, but anybody over the age of 25. So this is good, by the way. Anybody over the age of 25, once you pass your C of Q, so actually a couple of things. One, once you pass your C of Q, you only need to take 2 more courses in order to get your fire alarm ticket. So through the CFAA, the Canadian Fire Alarm Association, you were required to take 5 courses. But because you have your C of Q and you did trade school, 3 of those courses are taken care of. You only need to take 2 more and then you have your fire alarm ticket. Having your fire alarm ticket and being an electrician, holy crap, you will get paid very, very, very well, especially if you go to like the nuke plants, because they have a really hard time finding electrician fire alarm people. So the other thing is teaching. There is a huge, huge, huge shortage in colleges of teaching. All of the boomers retired when COVID hit. They didn't want to switch to online because they didn't know how to use technology, whatever. Some colleges will basically, you have your C of Q, they'll hire you to teach. A couple of colleges are like the higher college, like George Brown and Humber are a little pickier. But most of the colleges, Centennial, Sheridan, Durham, if you have your C of Q and you have like a good amount of experience, they will absolutely take you in for teaching. Now, you want to ask me, how well does teaching? You don't want to do full-time. Full-time pays less. Part-time is the way to go. So you are only allowed to do up to 12 hours per college. That's it. Now, ask how much we get paid an hour. You guys are pretty darn close. Because I actually am helping Sheridan out and I went over 12 hours, I am making $85 an hour at Sheridan. I'm at $110 an hour at Humber. And I am at $96 an hour at Loyalist. So between these three colleges, I work roughly 22 hours a week, give or take. And I brought home $110,000 last year. If I were to get full-time at, say, Humber, they would only pay me $78,000 as like starting off. I would only get paid $78,000 and I wouldn't be able to work at any other college. So I actually prefer working at other colleges because I make more. Every year I go up another $5. So this July, I'm going to be making $115 an hour at Humber. I'm going to be making $104 an hour at Loyalist come September, like that sort of thing. You're getting, okay, the reason we get paid so much though is because it doesn't, that's per teaching hour. It doesn't take into account the time I spent making all the PowerPoints, making tests, grading projects, things like that. Fire alarm 309A, if you were at the nuke plant, I think you're making $57 an hour, maybe a little bit more. If you get into a fire alarm actual, like Toronto commercial fire alarm place as a fire alarm tech 309A, I know you start at 45 and go up to 70. I'm a part of Mike SW union all the time as an electrician, but I'm also part of OPSU union as a teacher, and I get benefits and pension and all that other crap too. Sorry, yeah, right, you can get fire alarm for under 25 years old. Sorry, I meant the teaching. They probably won't take you if you're under 25 for teaching. Sorry, my bad. The ADHD, I had two different things there. But I'm just saying that once, and you don't have to teach all the time. So a lot of the time what we have are people who work out in the field, say Monday to Thursday, and then they teach just on Fridays. Or they teach just at nighttime, or they teach on weekends. And you get to pick, like you only want to teach Tuesdays. And you get to pick that you only want to teach electronics or you only want to teach PLCs. They completely work around your schedule. Lots of that at Humber. What? Lots of what at Humber? Yes. Yeah. So I'm one of the few people that once I got into teaching, to me, it doesn't make sense because I used to be at the nuke plants. I would work 40 hours a week at the nuke plants and I was bringing home $1,800 a week. Well, I'm working 22 hours a week right now and I'm bringing home like a 10 grand a month kind of thing, right? So I'm making more money and less work. Also, I've got kids. So when my kids are sick, sometimes I just bring them to work with me or I can switch to online. Was it like working at the nuke plant? Boring, unbelievably boring. Hated every second of it. I'm a thinker. I can't just pull wire for 40 hours a week. Like that's suicidally boring for me. The pay's really good. but it's very boring and there's a lot of rules. And if you fuck up even one rule, you're gone. It's also, God, it's so gossipy and so backstabby up there. It's awful. But if you've got kids and you ever want to buy a house, you got to go union. You will never be able to buy a house, have a family if you're non-union. Sorry. So either way, just so you know, those are options, especially with the teaching. And especially for my ladies, I'm the only female teacher I know. Beverly and Madison, I'm the only female teacher I know. I'm the only one I've ever been around. It would be nice to have one more. Jesus. But yeah, like, so Durham, Fleming, Centennial, Sheridan, I think Seneca, like, basically you just look at their careers page, put your resume in, guaranteed you'll get a phone call and they'll say to you, hey, can you start yesterday, kind of thing. And if you get more than 7 hours, you're like at $100 an hour or whatever. So that's pretty nice. There you go. Are you saying lies? Sorry, Max. You can't make enough doing resi to buy a house. You can't. Have you seen the state of the housing market right now? Oh, no, not all non-union is resi. That is correct. However, let's be honest, the majority of non-union is resi. I went to the bank. I made 110 last year. I think I made 102 the year before, and I made 98,000 the year before. And the bank says to me, we will give you a mortgage for $450,000. And I'm like, great. There isn't a single house there's no houses. There's no houses. So even I'm making what I'm making, I can't get a house because this is all they'll give me. And my mortgage payment would be $3,200 a month. So I'm just like, okay, cool, thanks. No, thank you. With a $500K down payment. So yeah. It's a good time. How many of you are non-union, by the way? All right, well, I happen to know that CUSW is looking right now to take on more people. Journeyman, once you guys are journeymen, CUSW is looking to take more on. CUSW is the one that does Hydro 1 and all of the nuke plants, all 3 nukes. So if you want to make actual money, CUSW is the union you want to go with. See, Mark, thanks for backing me up. Got paid almost double what you're making. It varies between the different collective agreements, but generally it's between $50 to $70 an hour journeyman rate. CUSW by far. Because CUSW has Hydro 1 and all 3 nuke plants. IBW lost all their big contracts to CUSW, and they mostly just do slab work in downtown Toronto now, so sorry. That is very true. Yes, but you were considered one of the few. Who do you see as electrical contractors at OPG, my friend? Nathan. Who do you see contractors for electricians? What companies? Okay. Who else? Black and Mac. Yeah, those are IBW, but who else? So fun story, Nathan. But 30 years ago, a bunch of people got really pissed off with IBW and split off and formed CUSW. There we go. CUSW was looking for contracts and things like that. Well, Black and Mac, Aecon, and Fox are all IBW. OPG and Bruce Power did not want to deal with IBW anymore. But because they can't just break the collective agreement contracts with Black and Mac, Aecon, and Fox, what they did instead, because Black and Mac now lost all the contracts, because of IBEW electricians sucking so bad, Black and Mack then formed a company called BD Power. And BD Power went with CusW. Aecon lost a bunch of contracts with OPG because IBEW electricians fucked up. And Aecon formed a company called Braemar, which is now called actually something else. I forget what it's called now. Shit. I forget what it's called. And then they went with CusW. Fox lost all their contracts at OPG because IB electricians fucked up. And Fox bought a company called Montgomery. And Montgomery went with CusW. So 95% of the electrical work done at all three of the nuke plants is done by these three companies, which are with CusW. There are a couple other ones, but these are the original IBEW companies that formed smaller companies, and then these companies went with CusW. Whole lot of union beef, yeah. Hydro One is 99% CusW, and Villard is another one. Villard is the TransCanada. Villard is also with CusW. Is there anything rivaling CusW? No. CusW has all the big shit now. CusW doesn't do any resi or any commercial. It's only the big shit, only the huge industrial stuff. Now, it does have some smaller, what do you call it? So when you want to join CusW, what they do is they give you a really crap job just to see if you're going to be a dick. So they'll give you like a 2-week job doing solar panels. And then as soon as you're done the 2-week job doing solar panels, then you can get a nuke job. Because that's how they're able to like weed out all the crappy people. Because the crappy people are like, I'm not working at solar panels for $25 an hour. They're like, fine, then go. Just suffer through the 2 or 3 weeks of doing solar panels, and then you get into the nuke plants. Oh yeah, of course they do. Absolutely. Do you think your job is more secure with CusW? I would say so, yeah. Pickering just announced its refurb, so they're going to be doing crazy big hiring at Pickering soon. Like very big hiring at Pickering. And Hydro One, you can get into Hydro One on your own. It's extraordinarily difficult, but you can get into Hydro One through, if you are in CusW, you get into Hydro One, or if you're in the Power Workers Union. That's another one you can look into. The other union is Power Workers. Both of these unions will get you into Hydro One. Or if you know someone, yeah, it's almost, if you try to get into Hydro One on your own, it's next to fucking impossible. But if you're in CusW or PW, Power Workers Union, yes, then you can take, like my first job was Hydro One. So. No, CusW's linesman. Well, PW has some linesmen, but CusW is linesman. Why did you leave? Because I'm teaching. This is way better. I'm literally here in my pajamas. I just ate spaghetti. I'm drinking cold coffee in my house. This is way better. Being on I'm old, man. My knees hurt. This is way better. That's the dream. Plus, and to be perfectly honest, I'm much better at this. Like, I was a slightly above average electrician because, again, I was at the nuke plant. So it was just like hanging things and, like, I don't know, running conduit. Like, whoop-de shit. Like, yes, was I getting paid well? Absolutely. But you weren't wiring anything. Like, it was, I did mostly Wi-Fi while I was up there. This is more suited to me. I like teaching better. It is because I get to call you all potatoes for free. It is. You have no idea how much joy it brings me. I get to be mean. I know. You have no idea. When I first got hired, I didn't even know what the pay rate was. It was COVID. I needed a job. I had just had a baby. And, I got laid off. Well, I was on mat leave. And then I didn't want to go back to the nuke plant. And I just started randomly looking and I'm on, teaching. And they hired me and I thought it'd be like $35, $40 an hour. And they're like, no, we're starting you off at 96. I almost puked. I was like, are you seriously? And they're like, yeah, this shit teaches, like, pays really well. I'm like, oh, it's great. I love that. I know I can't believe I get paid for this. I get to shove knowledge into your face holes and I get paid for it. And I get to call you potatoes. There's some free job advice. Anyway. Transformer impedance, PP. Yes, let me find it. Extra info. Oh my Lord, hold on. Transformer impedance. Okay. Hold on, I do teach high schoolers. There's an OYAP program where, if you're not familiar with the OYAP program, it's like literally start trade school for them in like grade 12. And so I have had to teach high schoolers. It's weird because I clearly, as you hear me teach, I have to be very, very careful with the swearing and not so much with the thick, juicy stuff. So it's a little weird for me. I do have to be PC with the high schoolers, yeah. Okay, transformer impedance. What is it? It's a general term for resistance and reactance that hinder alternating current in a transformer. Remember, hinder. So it's basically efficiency. That's why it's expressed as a percentage. Let's see here. Come here, next slide. Do you actually, you want me to teach it or you want me to teach the math? Ian, do you just want to do the math? I already kind of talked about impedance. Here's the math on this bad boy. Okay, here we go. Why do we care about impedance? Again, essentially, it's the efficiency. Power factor is also efficiency, but power factor is more the efficiency. Because it's kind of funny because they're both kind of the same thing. Power factor is expressed as efficiency on the high end. So you're looking at it as 80% power factor, 90% power factor. Impedance is expressing efficiency on the low end. So power factor is specific efficiency. Impedance is the culmination of all the things that's preventing it from being efficient, if that makes sense. So impedance is the culmination of resistance, capacitance, and inductance, all the things that are stopping it from being efficient. Power factor is this is how efficient it is. So that kind of makes sense that way. So we use a Z. Again, I don't know why. It's the percent of all of the things that are preventing the transformer from being super awesome. We use it to calculate available fault currents and, most importantly, to determine whether two transformers are suitable for paralleling. Do you guys all know what fault current is? You know what a fault current is? No, yeah. Fault current? No. No one's answering. No, seriously? Oh, okay, weird. Okay, so the fault current is when something goes to shit and the electricity goes to ground, you need to factor that in. Because we all know about the grounding and the bonding and how to size the wires and stuff, and that's great. But when you think about it, if lightning strikes your house, it's not the 100 amp panel you need to worry about. You need to worry about that electricity from the lightning that's currently going through your house, through all of the bond wires, into your actual ground rod or grounding electrode into the earth. Now, a couple of the things that affect this are the power of everything in your house, your impedance, but also, oddly enough, the soil and like the dirt that the ground rod is in. So one of the things, especially when you're industrial, you have to do something called a ground grid. So before any industrial commercial building is built, what you have to do is you literally have to run a ground grid of grounding conductors. And you do it exactly like this, and then you have to CAD weld each single juncture point, and then you've got literal ground rods pounded, like the grounding rod electrodes pounded all the way, roughly 10 feet, 6 feet, whatever, all the way into the ground. And then you've got your tails coming up and attaching inside of the building. So if there is a fault current and something goes to shit and all of a sudden there's way too much electricity, it's going to travel into here and then it's going to dissipate through all of this stuff. And one of the things you have to consider, if you remember that table about the touch and the step voltages, the moist soil, the organic soil, the clay, different types of soil dissipate electricity differently. So if it's wet, it's not going to dissipate it as well as if it's dry, if it's clay, all that type of stuff. As electricians, we don't deal with that. You get some geologists and some electrical engineering people, and they figure out the 0.2 fault current, 0.2 seconds, 0.5 seconds, what type of dirt it is, whatever. And that tells us what size of wire to use, how far apart they have to be, and how deep we put these ground rods in. So impedance is one of the things we have to use, and we want to figure out how big this stuff has to be. Because if you've got a really, really high impedance, that's higher hindering of the circuit. So a fault condition occurs when one or more electrical conductors short each other or to ground. The fault types are classified as phase to ground, double phase to ground, three phase to ground, which almost never happens, phase to phase, and three phase. So some of these happen more often than others. The easiest way to think of fault currents is a hydro pole. So you've got a hydro pole and it's got 1, 2, 3, and then the neutral coming out of it. What's more likely to happen? So a phase to ground is one of these breaks and goes to ground. 2 of these break and go to ground. 3 of these break and go to ground. Or this one breaks and touches that one. Or this one, all 3 of them break and touch each other. The 3 phase touching each other literally never fucking happens ever. But they have to account for it anyway. So the ones that are most common is phase to ground. One of them will snap and hit the ground, or all 3 phases to ground. Those are the 2 that happen most commonly, because one of them snapping and hitting the ground, obviously, yeah, and a whole ass hydro pole snapping and coming down, that's 3 phases to ground. Those are the most 2 common to happen. The fault current is usually, no, it's not usually, it is several times larger in magnitude than the current which normally flows through it. You've got 3 phases and you've got 100 amps, 100 amps, and 100 amps. All 3 of these bad boys bust and hit the ground. Well, now you've got 300 amps all going through one very tiny little spot. It's bad. Now you've got your 3 and they get hit by lightning and they hit the ground. So there's all different types of things you have to factor in. So in that kind of regard, we have to do fault interruption devices to make sure that this doesn't happen. So as soon as something snaps, like one of the wires snaps, it lets the overcurrent device know, so everything gets shut down. Circuit breakers, fuses, overload relays, meow, meow, meow. The other thing we use impedance for is, can we parallel? So the 3 rules as to whether or not we can parallel a transformer has to be voltage rating, same polarities, and same impedance. And we had that question earlier. I can't remember which one of you asked me to redo it, but it was the polarities. The polarities have to be paralleled, because if you don't parallel your polarities, you just series to transformer, which is unbelievably dangerous. Don't ever do that. Unless there's a zombie apocalypse, then all bets are off. You can do whatever the fuck you want. Heck you want, sorry. So to figure out impedance, we do something called a short circuit test. Got this lovely transformer here. This transformer is 4160 volts on our primary, 120 on the secondary. So clearly it's a step down. And overall, it's 20 kVA. So we want to check across our high side here. Our 20,000 kVA divided by 4160 volts gives us 4.8 amps on the primary. So that's what the primary can handle safely. Based off of this, our primary can safely handle 4.8 amps by our calculation. Anything more risks a problem and burning up your windings. We do the same thing with our secondary, 20 kVA divided by 120, 120, it gives us 166.7 amps on our secondary. Now we're going to short the secondary. So we're just going to short it. When we short it, we're going to put a voltmeter across our primary. And then we're going to slowly increase the voltage on the primary until we see 4.8 amps in our voltmeter. Once we do that, I already put it up here. Once we do that, we might end up with something like 104 volts. This is just a ballpark number. So we're doing our voltmeter. We're increasing the voltage slowly until we read what we calculated at 4.8 amps. Let's say we increase it to 104 volts. That's what we got in order to get 4.8 amps. That's what's called our short circuit voltage. Now, impedance equals E short circuit divided by what it's rated for. So it's rated for 4160, but we only had to put 104 volts in order to get that 4.8 amps. So to figure out our impedance, we just take this and divide by this. So our E short circuit was 104 volts divided by this, which is what it's rated for. And of course, because it's a percentage, you times it by 100. So that gives us a short circuit test, an impedance of 2.5%. 2.5%. So E short circuit divided by the rated voltage gives us impedance. Here's another one. Boom. So the first thing you do is you take your kVA, you figure out your amps on your primary side, your amps on your secondary side. So math. We end up with 3 amps on our primary, and we end up with 104.1 on our secondary. We then short out our second side. We remove it from the load. What are we going to do? Oops, that shouldn't say 4.8. That should say 3. I screwed that up. We're going to slowly increase the voltage on our primary side until we see 3 amps. You might get a really random number. 106 doesn't mean anything. That's just, it could be 127. It could be 5. We don't know. But in this case, I came up with 106. So we increased the voltage until we saw 3 amps. We increased the voltage, and at 106 volts, we ended up with 3 amps. Awesome. We now take that 106, we divide it by what it can handle, and that's going to give us an impedance of 1.27%. The lower the impedance, the better the circuit, the better the transformer. The higher the power factor, the better the transformer. So that is how you figure impedance out using a short circuit test. Ta-da! Jazz hands. Cool. And then, yes, you can also figure impedance out with your RLC happy, crappy circuit stuff as well. Like you remember how to do it that way. But this is the other way to do it using our short circuit test. Oh, thanks, Madison. Appreciate you. I keep getting GFI interrupting questions. What? Did I forget how to calculate it? I would need an example of that, friend. I think it's 2 milliamps for Class A. Ooh, maybe it's 6. Either way, it is in Appendix B, Section 2. That's what you're looking for. GFI interrupting amperes is, I'm almost positive, Section 2, Appendix B. It's either 2 milliamps or 6. I really can't remember. Is it 2? Yes. I'm actually really proud that I remembered that. Just in case you didn't think I knew what I was doing. Yeah, I do. It's 2 milliamps. Oh, they're interrupting time? Oh, shit. Is there a table for that? Fuck, is there a table for that? It might be an appendix. No, there isn't a table, but it is in the code book. Maybe it's an appendix D. Yeah, it's either an appendix B or appendix D. Because D's got a bunch of random crap in there too. I don't remember I don't remember the interrupting time off the top of my head, but it is, I know it is in there somewhere, so. Any other questions? Any other questions? I'm not gonna lie, I'm winding down here, guys. It's been going on 6 hours. I'm winding down pretty hard. You're very welcome. And again, if you want to send an email to Dan Hammond, that'd be fantastic. And you guys have my email address for if you need me. If you guys, when you find out whether or not, oh, actually, super favor, turbo favor. After, especially to Madison, because I think she likes me more than anybody else here. After you take your test on Friday, if you could email me as many questions as you remember, they don't have to be specific. Just email me and go, I had one transformer with an impedance question. I had 2 about cold motors. I had 1 or 3 about photovoltaic. If you could just email me and just give me as much information as you can remember, that would be freaking awesome. And then I would love it if you guys could email me after you find out how well you did. That'd be fantastic too. I always like to know how much I helped out. So if the majority of you email me and say you passed, then clearly I'm amazing. So that would be very helpful. What's my email again? Hold on. It is, J.Herrick. Must be J at live.ca. That's my personal email. I don't know. You know, Jackie, it's funny you asked that because a lot of the colleges, I don't know personally which one I like more. Whether it's the full week or whether it's like the weekly thing. I can see pros and cons to both. I think the colleges, when they were doing the weekly thing, I think they were having a hard time finding teachers to do it consistently. Like it's easier for me when it's just all day Monday, all day Tuesday, but it's harder to get me for just Mondays from 8 until 12, like consistently, you know? So I don't know. A lot of colleges are flipping and flopping. I can see pros and cons to both. Should be longer. Should be 2 weeks to exam prep. I don't know what else to teach you. At this point, oh, thanks, Madison. At this point, it's just doing as many questions. I've given you the tools. It's just doing as many questions as possible. Can you explain where to check on category of wires from section 18? I'm getting some more questions at category, but I only see zone. Ah, my friend. So when it comes to hazardous locations, we have the, pardon my French, don't fucking go there triplets. So we have 18, 20, 22. These only deal with zones. When you go to Appendix B, you get categories, but you also have Appendix J and something called Annex J. So it goes zones, it goes zones, category, and then you've also got divisions when it comes to hazardous locations. So you've got zones, oh my God, 0, 1, 2, and then zones 22, 23, 20, whatever the frig it is. And then you've got category 1 and 2, and then you've got divisions 1 and 2 as well. So zones is just 18, 20, 22. Categories is generally an Appendix B, and then category and divisions is in Appendix J and in Annex J. Sorry. Hazardous locations is an absolute disaster. You're not going to get anything hard with it. Trust me. Trust me. I don't even know anybody who's even had a hazardous location question. The only hazardous location questions I know of are the trick ones. Like, where is the hazardous location in a marina? Well, that's not in 18, 20, or 22. That's in the section called marinas. Or that one question we had where, when is a generator required to start up in a hazardous location? I don't know anyone who's actually got a hazardous location question. So I wouldn't go totally crazy with worrying about hazardous locations, honestly. Appendix B was section 18, Appendix B was section 20, and Appendix B was section 22. The diagram questions, are they more heavily weighted for a certain section? Absolutely. C and D. So C is where can we shove that, and D is the motor control. So D, section D is the motor, the wiring diagrams. That's where you're going to get those ones. And then section C is the how do we install this shit. So C is going to be the box fill, how many wires are required at point X, where do you ground this, like that kind of stuff. You might get a couple, obviously, for section A, B, and E. E is the 2 fire alarm diagrams, but they're mostly heavy with C and with D. I think I covered all, if not most, of the diagrams you are going to find. You're going to see. Like, you may be surprised by 1 diagram, 2, but definitely not 3. I'm pretty sure I covered all of the ones you're going to encounter. Can you do some more questions? Ian. Okay, but I need a 10-minute break, Ian. Or 5. Can I have a 5-minute break, Ian? You're killing me. I'm so tired. Okay, thank you. Sound good? Then you're cut off. And you're going to have to bug Brent tomorrow, and I think his name is Mark, on Thursday. He gave me I don't know. Mark? Something? I actually have no idea. I know Brent's got you for 8 hours tomorrow, and then I think somebody named Mark's got you for 8 hours on Thursday, I think. Is it Mark Kennedy? I wish it was Mark Ruffalo. Oi. Is it Mark Kennedy? I don't know. Hold on. Let me double check my email here. Oh, this is Sheridan. Hold on. I gotta Outlook. So I think it's Brock Sinden for tomorrow, or Sniden. I don't know how to pronounce it. And Michael. You've Michael on Thursday. I have no idea who Michael is. Michael. So Brock is tomorrow. Somebody named Michael is on Thursday. That's all I know. Oh, hold on. Maybe it'll be in the, hold on. Communication. Where's class list? Where's class list? It should be here under class list. Hold on. Michael Schneider. Michael Schneider. Do you guys know who that is? Michael Schneider. Oh, God, I wish. Yeah, no. Okay. All right. I've never seen these before, so we're all doing this brand new. Well, is it easier for me to see this way? It is not. Okay, so let's flip it this way again. What is the most common type of injury in construction? Contusions, fracture, or sprains? Oh, fuck's sakes, let's get this bigger. Sprains and strains, fractures, cuts and lacerations, or electrical shock. B, I already know this. It's sprains and strains. They're called musculoskeletal disorder, MSDs. When using 14.3 NMD90, the identified white conductor may be used as an ungrounded live conductor with a single pole switch wired in conduit. Never as a return. Oh, this is an old question. Because now you have to do the neutral drop. So this must be based on the 2015. This is an old, sorry, this is an old question. Because you're not allowed to use a neutral ever now. So I guess this one would be never. All right, the disconnecting means for a magnetic motor starter shall be located within sight and what of the air conditioner? Oh, there you go. There you go. Cold motors, 3 babies. 3. Oh, good God, I'm not doing math. Pressure of, you won't be asked that. What age group has the highest accident rate? 16 to 24, 35 to 44, 55 to 65, 25 to 34, 16 to 24, yep. When turning a bonding screw at the back of a device box, a proper tool to use is, you won't get that question. You absolutely will not get that question. According to the electrical code, throughout a run of NMSC cable, what is the maximum spacing of cable supports? Hey, does it seem like there might be a table for that? I feel like there might be. Also, you can find it in code under NMSC cable. So, section 12. According to the electrical code, if supporting of gang... Who wrote these? If supporting of gang device boxes is required and wood is used, the wood thickness must be at least... I don't know, but where would we find that? Which section would we find that in? What section? It's either going to be 12 or 26. Because 26 is installation of electrical equipment. So if it's not in 12, it'd be in 26. But if it was in 12, it would be in 12-3032. Yeah, 12-3032 probably tells you that. Conductors with insulation used to supply a group of motors shall at a capacity not less than blank of the largest FLA in the group plus blank % of all other motors. This one would be 125% of the largest flaw and 100% of all the other flaws. According to electrical code, the minimum amount of free conductor, floppy conductor, on each cable at an outlet box must be. Oh, see, this is, actually, I like this. If you'll notice, and this is something the CFQ would do, 2 of these are in centimeters, and a couple of these are in millimeters. So make sure you pay attention, because the CFQ will do that as well. Oh, that's actually a good question. I don't know the answer to this. What size of machine screw is used to mount a switch to a device box? 632? I feel like it's a 632. Yeah, that feels right to me. What is the minimum copper AUG size of 600 volt RW or R90 conductors that can be installed in RMC to feed a 30 horsepower, 460 volt, I think it's three-phase continuous duty motor with a service factor of 1.1? Aha! I like this question. Do we care about the service factor for this question? No, it's useless information. We do not care. Is the motor hot or is the motor cold? Seems pretty hot to me. So, step 1, find your flaw. Then we have R90. There's no termination temperature mentioned. So 4-006 applies. I'm going to go with 60-degree column. So your flaw based off of 60-degree columns could probably going to give you 30 horsepower. It's probably going to give you number 12. No, 10. I don't have a code book in front of me. I'm just going based off my brain. The main cause, 32 flaw. And then 32 continuous duty, 32 times 1.25 gives you what, 38-ish? 40, I was close. And then 40 in the 60-degree column. I guess it would be number 8. Jesus. Yeah, that's number 8. Beauty. The main cause for construction fatalities is falls, hit by falling objects, electrocution, misuse of power tools, or hit by moving equipment. It is falls. Absolutely, it is falls. You will never get asked about what glasses are made from. No one. Nobody's gonna know that. Who's gonna know that? Jeez. If a motor installation requires that the motor supply conductors be rated in excess of 75 degrees, the conductor shall not be less than how many long? Is it? Double check, because this says rated in excess of 75 degrees. What a 28, oh shit. 202? The 28202? 2204. I would double check this. I know it's 1.2 meters long, but this says rated in excess of 75 degrees, so I would double check this. Is it 28? 20 something? 204? $104. Okay. Yeah, me personally, I would double check that one. I wouldn't just go 1.2 because I see it there. They might be trying to fuck with you. It's still 1.2? Beauty. Love it. Oh, is that it? Only 16 questions? Oh, okay. Oh, okay. Hold on. Let me grab another one here. Whoops. Thought there'd be more than that. Where do I find that? Practice assignments. 2. Download. 3. Download. 4. Download. Okay. I'm already checked out for today. Don't say that we need her. No, I'm already checked. The Sheridan practice isn't good. No, I don't like these at all, but I've run out of my stuff. So you guys weren't supposed to be smart. I know that sounds funny, but I always run into the problem of I always have to teach something, kind of like how I did the hermetic motors. So normally my stuff lasts more than 2 full days, but you guys aren't stupid, so I didn't have to like teach you anything. Does Sheridan? I have no idea. Actually, I have no idea.